This
Just
conference will now be recorded.
so yeah, just a moment.
Okay.
I'll just give us like a brief introduction, and then we can go back to the session. So a very good morning or evening. So as we all present in different parts of the world. So yeah, I'm not sure if it's morning, evening, or night. So anyways, we're
Yeah.
really happy to welcome you all to the webinar today. And myself, Sarah Williams, Conference Secretariat at Coalesce Research Group LLC, very delighted to welcome you all. So even during this pandemic, it gives me immense pleasure to having meet you all virtually at the webinar organized by our company, Coalesce Research Group. Coalesce Research Group is an USA-based emerging open access publisher and international conference organizer which hopes to serve the scientific community by serving the high-quality, genuine research work from eminent scientists, professors, scientific research communities in all fields of medicine.
Hmm? Excuse me, I don't hear from you.
Something wrong.
Yeah. Do you hear me?
Yes, you're okay.
Oh, yes,
But
I
Sarah is
hear
not here.
your voice, but
Yeah, I'm not sure what happened to Sarah.
Maybe early morning.
Morning.
Could be.
It's 2 o'clock in the morning here.
2 o'clock in the morning? What?
Yeah.
Where is?
In Oregon, USA.
Wow, it's too early. I'm in Tokyo, and so 7 o'clock in the evening.
Yes, I know.
I'm trying to make dinner
Yeah,
after the presentation. But anyway, I think we can start my presentation, right?
Yeah.
Okay, my presentation, the title, next generation recycling process by using, I just call their intelligent comminution. Comminution is their very broad term, and breakage or crushing or grinding, and so any kind of breakage mechanism, and the intelligent sorting, physical separation processes. And wow. Oh, yes. This is the very fundamental technological flow in the resources recycling. And the start, the waste materials and usually fed to first their comminution and the crushing or the grinding. And so for the purpose of their liberation of the composition of materials, and hopefully there is sometimes the selective grinding, and so volume reduction. And there, if we like to recycle or upcycling or horizontal recycling, and so we should give there some technology, separation technology, and physical and excuse me, okay, pointer. It's a pointer, physical or chemical separation, and the combination of the two technologies must be necessary, and then we can reuse after physical separation or chemical separation. But today's my topic is usually focused on these two kinds of technologies, and so one is the combination, the other one is their physical separation. And so what is the difference of the physical and the chemical separation? The property is there in physical separation is usually utilize solid property without destroying atomic configuration. We can sort the waste materials, for example, waste materials one by one by the particles. But what about the chemical separation? Is the another one is it's a chemical can be classified into the two categories, and one is in the case of metaphases, then the pyrometallurgical processes and the hydrometallurgical processes, and the property of which it must be destroy the atomic configuration, and by dissolving and doing that. And target materials of the physical separation is, of course, the solid particles, which is very, very heterogeneous, and so not so easy to be separated from each other. And the target of the chemical separation must be the molecules, ion, but basically in elemental phase. And what is the environmental impact have to be generated from these separation processes? Physical separation probably very, very low, because then the particles can be separated from each other with not much energy. That the chemical separation, we can dissolve into some solvents, or we can melt by adding the much amounts of energy, and environmental impact is very, very high. But theoretical background is very poor in the physical separation, because the targeted particles to be separated is very, very heterogeneous, and only the basic theory and they have. But in the chemical process, chemical separations, the technological background is very rich, and the reliability of the separation is a little bit lower in the physical separation, but higher in the chemical separation. But problem must be their energy required in the chemical separation, because too much energies have to be required, and we should improve the technology of the physical separation and solid phase separation. But of course, it's very important. It's the effective combination of both technologies are required for environment friendly recycling. And the first, and I would like to tell you their intelligent combination, intelligent breakage. Because unusual breakage must be the very, very random. That we propose their intelligent breakage. This is the one example: recovery of platinum group metals from spent automobile catalyst. For example, the automobile catalyst and the shapes are like this, and so-called converters, and to clean up the discharged gas from automobiles. But the microstructure of the converter is like this, and the cordial-like lattice substrate and is covered by their alumina phase with not much, but a little bit a small amount of platinum group metals, and the platinum, then the palladium and rhodium. Then, so how to recover these kind of PGMs? This is the technological point. But usually all now present processes for the recovery is very, very not simple. But one is all converters should be crushed very, very finely, and then all the materials and have to be melted into the copper molten phase, because the PGMs is very, very like they're copper molten, and then PGMs in a small content is gradually moving to the copper molten phase, and can be concentrated as their PGM and the copper alloys. And then after that, then the finely ground again these molten phases, and the dissolve into the very, very strong acid, then of course aqua regia or something like that. And then the PGMs, palladium, platinum, palladium, rhodium, can be recovered finally by using their solvent extraction. But I think the PGMs, platinum group metals, is only existent in the alumina phase, not in the cordierite phase. And then we propose the new process and the two, first of all, to separate their alumina phase from their cordierite phase. And of course, this is their catalyst. Then if we apply the heating quenching process before the breakage, this is the microstructure of the cordierite and the alumina phase before heating and quenching. But after heating and quenching, of course, there the alumina phase, between the alumina phase and the cordierite, we have a very large cracks here. And then we can separate only alumina phase from the cordierite. And also in this, from this side, right hand side is alumina and left hand side is cordierite. This is the before heating and quenching. But after heating and quenching, these phases can be changed into like this. Only the alumina phase can obtain their many micro cracks inside. And then we can separate from alumina phase from the cordierite like this. And also we can make a selective grinding of the alumina phase. And then, this is their computer simulation of their, oh no, cannot work. Okay, anyway. And then why the alumina phase can get the many micro cracks? Because the B shows the stress applied by the heating and quenching, and the cordierite phase only the compressive force is only applied to the cordierite phase. But in the alumina phase, the tensile stress can be made in the alumina phase, and then the only alumina phase can be broken into very fine particles. And then this is the conventional process is all the converters can be crushed very finely, and the pyro and hydrometallurgical processes to recover platinum group metals. But we propose the new process. We add the new process. First of all, they are heating and quenching and selective crushing and grinding. This is the intelligent combination. And then after the intelligent combination, applying the intelligent combination, we can make a size screening, and so fine particles, the only alumina phase can be concentrated in the fine particles, and coarse particles, there only the cordierite phase can be concentrated. But of course, their reality is they're not so simple, and then the intermediate size particles still contains both mixture. But the alumina is oxide, that their cordierite is silicate, and the surface electric potential is a little bit different from each other in water phase. And then we can apply their, it's a very classical technology, flotation, that's developed in the mining site. And then we can concentrate only alumina phase as a froth. It's a hydrophobic phase. And then only the alumina phase, which contain their platinum group metals, can be fed. Only the alumina phase can fed to their energy intensive these processes. And then we can reduce the total energy less than half. It's very energy saving process. Oh yes, over 50% energy can be saved. And also recovery of minor metals from their e-waste. Oh, but the time is very short. And then we only, and so we give you the photo, and this is a little bit, this work was done in almost 8 years ago, and old-fashioned and mobile phones, but we applied their very special breakage stress and to the mobile phone. And then they only their here must be their printed circuit board inside, but no printed circuit board we can see here, and so no breakage occur on the body. And then we can separate only, we can remove their printed circuit board from their from the body, mobile phone body, in almost non-destructive form. And also there these and printed circuit board can be fed to their another special crushing methods. There the parts installed on the PC board can be also removed like this. And their printed circuit board is of course in a non-destructive form, and also their parts, many parts is almost non-destructive form and can be removed from the board. And so we can control their the condition, and so to separate, to remove all the parts, and there's some selective parts and parts removal we can conduct. And we applied many kinds of the crushers, and so involving newly developed crushers. Then this is the relationship between the detachment ratio of the parts from the board, from the printed circuit board, and the breakage ratio of the parts. We like to remove any parts in non-destructive form, because minor layer metals is usually involved in some specific parts. And then if we can remove such kind of parts groups, and so we can make their part separation from each other, then we can concentrate minor layer metals. And the good this is their 100% detachment, and so 0% of the breakage ratio. This must be these. For example, this is the name of the crusher, the part separator. It's very good for this work. And so almost their cross-flow shredder is almost very good. And so detachment ratio is very high in any elements involved in the parts, and breakage ratio is very low. And also, and so some specific hammer crushers is also work very well. And then we can calculate the cumulative energy, and then this is the relationship, the cumulative energy applied in the crusher and the detachment ratio. The ball mill is which is very classical grinder. Is the cumulative energy is consumed, not the detachment, but the breakage. But their newly developed hammer crusher part separator cross-flow shredders is very well, because the cumulative energy, the energy is usually supplied to detach the parts, not break the parts. And this is their a little bit old-fashioned computer simulation. But unfortunately don't work. Yeah, much different from each other in the parts separator and the ball mill. And so what? Okay, anyway, the time is limited. Okay, and next one, I will like to tell you the intelligent separation. And in other words, it's very famous, and the name is the familiar name is a sensor-based sorting. And the horizontal aluminum recycling by using X-ray transmission and the X-ray fluorescence sorting. The alumina is there usually, this is in Japanese case, and all the primary aluminum is it have to import from foreign countries. But and so we produce the road product of Indo-Sasha aluminum cans. But after the utilization, most of the scraps have to be mixed, and then anymore cannot be recycled as the primary aluminum. And these scrap aluminum, mixture of the aluminum alloys, have to be produced as the secondary aluminum. It's a low-grade aluminum, and usually usually used as their cast products, such as the automobile gasoline engine. That we developed the new technology. They're mixed scrap aluminum alloys and can be separated from each other. And then we're going to again their primary aluminum. And so this is the horizontal recycling. And this flowchart is just show their conventional process, the magnetic separation, eddy current separation, and the heavy media separation. And so finally we get their mixture of aluminum alloys that cannot be separated anymore. But our process is their X-ray transmission sorter and the X-ray fluorescence sorter. We can combine the two kinds of very, very high sensitive sorters to, first of all, to concentrate the mixed aluminum alloys. But finally, this is the window sash low materials, aluminum alloy, 6063 aluminum alloy from other aluminum alloys. And also by XLT and XLF sorter can recover only 6063 aluminum alloys from the other aluminum alloys. But we developed new sensor-based sorting. This is the Libus sorter. The Libus and Libus is a laser-induced breakdown spectroscopy, which analyzed the elements from hydrogen to uranium in the order of the ppms very, very precisely. And then we put this on the Libus sorter, and for the mixed aluminum alloys. Aluminum alloys are usually classified into the 8 kinds usually. The 1000, 2000, 3000, 4000, 5, 6, 7000, and cast alloys. And their separation efficiency, separation grade of their by using this and the Libus, newly developed Libus sorter, the recovery and the grade of each aluminum alloy is almost 100%, and which is very, very enough for the reuse as a primary aluminum alloys. And finally, I would like to propose the next generation metal recycling process. And so by using intelligent combination and intelligent sorting, and I already showed the 2 kinds of the processes. And first of all, the most important must be there how to break the waste materials, and the breakage, the objective, most important objective of the objectives of the breakage must be their revelation of the compositional elements. And so probably then we can apply many kinds of very, very intelligent breakage processes, such as I already told you, the heating, quenching process, and also the electrical disintegration, and so others. And so we can apply these kind of intelligent combination to revelate compositional elements, hopefully in coarse size. And then we can apply, if the revelation is realized by applying these kind of intelligent combination, we can apply high performance sensor based sorting, the combination. And so of course, and we can analyze very, very simply size, shape, and color, roughness, hardness, electromagnetic property, and the luster, and the wave absorption, density, and chemical composition. Chemical analysis also we can make by their sensor-based sorting. And the physical separation. This is not the perfect separation. Was not the perfect separation, just like probable separation like this. But by applying 2 kinds of intelligent combination and separation, so which is sorting, is we can realize their the sensor-based sorting, even by their physical separation. And then the final, this is probably the final last slides. And for example, they are this shows their energy consumption to produce 49 copper, very, very high purity copper from natural resources. How much is the energy consumed? Almost 25. But conventional recycling process, we can reduce the energy, total energy, necessary energy to their 7.2. And if by applying our technologies, which is intelligent combination and sorting, the energy can be reduced to 2.1. Very, very few energy have to be required. And of course, this is the concept and cumulative energy consumption by applying their any kinds of processes. Usually this is the conventional process, disassembly, and so usual crushing and the usual sorting, and then after that the pyrometallurgy, and so electrowinning can produce the 49 copper. But their new concept, new generation recycling technology must be like this: intelligent crushing, intelligent separation. Then we can quit their pyrometallurgical process. Of course, not for all the materials, but there are some of the materials we can quit the pyrometallurgical process. And then we can reduce the total necessary energy very, very much. This is my concept. And this is probably the next generation metal recycling process. Thank you very much for your attention.
Thank you very much, Doctor. It was an informative presentation from you. Yeah, any queries?
I think you are from a very, very variety of the scientific field, and so probably these kinds of recycling technology is not familiar. Especially
Okay.
physical
Can I
separation.
continue with the next presentation?
Okay, thank you very much. Yeah.
Okay.
Thank you. It was
Okay,
very
next.
interesting.
Yes, actually, the next presentation by Dr. Go Chi Kyong. He's unable to join due to some issues regarding internet. We'll continue with the presentation from Dr. Ramiro Pilcozola from University Mayor de San Andres, Bolivia.
Yes, good morning.
Good morning.
So can you see my presentation?
Oh,
Hello.
no.
No.
Okay. Hmm. Yeah, now it's better.
Not yet.
Dr. Shuji Oda, can you exit from the screen?
Oh, excuse me. How I can
Ah, yes.
reattach camera? I don't think so. Oh, is this probably?
Yes.
Is
It
it?
works.
Yes.
Yes.
Dr.
Oh,
Ramiro, you can
sorry
share
about
the
it.
screen.
Yeah, I'm trying to share my presentation.
Yeah.
But this is, wait a minute. So I am. ¿Dónde sería la presentación? Me toca ya. ¿Verdad?
Sarah, I already stop sharing my. I think so, but
You can click the screen button on the bottom.
Yeah, please click on the screen button.
But the screen doesn't respond here. And yesterday I was trying and it was okay. Okay, now it's going. Yes, now it's going. Yeah, okay.
Yes, we can see.
Yes,
Mm.
yeah, it's going slowly.
Yes, we can see your screen.
Yes, yes. Okay, now it's okay. So today I want to show to international community the environmental problem due to climate changes regarding to Titicaca Lake in South America. Also, from this work is part my colleagues from Sweden and from Surrey University, from Lund University, and the rest are Bolivians. So this is my content for today. I will talk about some background, objective, then about the Titicaca Lake and climate setting, so which is evaporation models and data used, downscaling and bias correction, trend analysis, climate change signals, and extreme PP precipitation indices. So then I have results and preliminary conclusion until now. So this is the background, the context. Here we can see a very nice picture obtained by Jim Allen. He is an Englishman. And here we have the Altiplano, a huge basin where two big lakes are placed in the North Titicaca, in the south Popo Lake. So those lakes are joined by a river, the Saguadero, which is called. And this place is, yes, in the world is placed at very high elevation, as you can see, almost close to 4,000 meters above the sea level. This place is preceded by paleolakes, by several paleolakes, and today just we have those two big lakes, and with serious hydrological problems due to climate change, I can say. So what's the situation in this region? We have strong climate variability, that's the characteristic. And now we have climate changes impact on this the warming in this area is the highest in the world. And why is the highest in the world in this place, at this place? But also the lakes, I can say, enormously are being affected by anthropogenic factor. Furthermore, as you can see here, famous medias were reported about the ecological catastrophe that happened some time ago. This is the Popo Lake, which is completely dry. This was obtained by Landsat in 2015 years. And you can see here in the other picture the fishes that died due to dry out of the lake, and because not only the water disappeared here, but also in the upstream lake, the water level has decreased. So, and this is the paleo lakes. You see, many authors, previous authors, have reported about old water levels. Just I want to mention that at the just at previous of the Holocene, there was taking place Tauca phase lake, in fact, and that means that the whole Altiplano, which is almost 200,000 square kilometers of area, has filled by water, and that time the water depth almost has reached 50 meters, 40 meters in some places, as you can see here. In the north here we have the modern Titicaca Lake, and in the middle the Popo Lake, and in the south the big salt plants like Uyuni, and this is very big area where today the lithium is trying to be extracted. So with this picture, I can tell you that already the climate changes and the water level has dropped before, and for several times. Sometimes, just as an example, the water level at Titicaca Lake has dropped 20 meters below the spills, also like 100 meters below the spills. Just some decades ago, also 3 meters and 5 meters below the spills. So already the Titicaca Lake, in the last time, was in the status of terminal lake. So this is my objective, is to analyze the long-term potential evaporation from Titicaca Lake for the different climate changes scenarios, because the evaporation is the main factor of the lake status. So the specific objective is to identify and to analyze the presence of trends in different climate variables, including evaporation from the open water surface, using the Mann-Kendall test and the sense slope estimator, likewise to find the possible climate change signals in temperature and precipitation. So some few words more about the Altiplano. So here in the picture, you can see the whole Altiplano, but in the upper part, we have the TDES system, which is Titicaca, Desaguadero, and Popo, and part of the Salares. So you can see here the whole area. And so yes, the Titicaca Lake feeds in a distance of like 300 meters by fresh water to Popo Lake. And today Popo Lake is very salty, it's very contaminated. And what is the area of the Titicaca Lake, for instance? The watershed area is it's like 50,000 square kilometer, and of the Popo Lake is just 25,000 square kilometer. The water surface of the Titicaca Lake may range from 7,000 to 9,000 square kilometer, and of the Popo Lake in average is close to 3,000 square kilometer only. The maximum depth of the Titicaca Lake is close to 300 meters, and the Popo Lake is very shallow, and the average depth is just like 1.5 meter. And of course, this lake is very sensible. That way, I'm trying to be focused on both lakes. So almost during the last 10 years, almost every year the Popo Lake has dried out. Or every year. Today, the lake almost is completely dried. Okay, about the climate in this region. So why, this is the question, why the warming at this latitude is the highest in the world? So that was reported already by summer reports. And here in the picture, we can see that this is the Atlantic Ocean, and here is the Pacific Ocean. And we have this work comes from Garut and Villiers. So I will try to explain about the situation, about the moisture flow during the austral summer, which is from December to March. So at this top, the altiplano is placed. You can see here the altitude, it's just close to 6,000 above the sea level. And the flow comes from the Atlantic Ocean, passing through the Amazon, and of course we have here the adiabatic process. And then at the top we have the dry air condition, and this can be a perfect condition for warming. But also the geographical position plays an important role, because since we have very high altitude or elevation, so we have the global radiation is very high at this altitude. And then, of course, there are another local conditions that are factor to be warmer in this area. But also the region is very arid, you know, and the land cover it's very low. The vegetation cover, I can say, few water bodies in the area. So those are the geographic contents. And what is the temperature at this region? It's like in average, it's like 10 Celsius degrees only. But during the day, we have extreme diurnal variation, and it can change from, like I can say, from 3 up to 18 Celsius degrees. The water surface, for instance, in the Titicaca Lake is 4 degrees Celsius higher than the air temperature. Water is warmer than the air temperature. But in the Titicaca Lake region, the precipitation is still today is quite important, and it can be like 1,000 or just around 1,000 millimeters per year. But in the southern, this precipitation is very little. It's just like 300 millimeters per year. So that is the context. And then for testing the climate changes effect on the lake evaporation, we in the previous work we tested several, like this is simple models, like energy balance approach model and payment approach. And today I will show you the results applying payment approach only, because this is this equation demands very few data in respect to other ones. And then this is my data that we used. So we here we are using daily data of temperature, minimum temperature, maximum precipitation, relative humidity, sunshine hours, and wind velocity for the period 70 and 95. And here you can see the summary. And yes, I told you already that the summer here is December and up to March, and the minimum can be at least in this period like 4 or 5, the maximum 14 degrees, and in winter time, yes, we have negative values. And the precipitation, yes, again in Austral summer is the highest. Here just we are trying to see close to 200 millimeters. This time also the humidity is higher, and the oppositely, yes, the sunshine hour is less, and the winter time, which is the middle, is higher. Since we needed the daily data, so the missing data, we fill it using the weather generator. And here you can see the statistical parameters, statistics parameter. And yes, we agree that we obtained good values, and that means that then we are having full series data for this period. Then, okay, we did downscaling, statistical downscaling for all the variables, a daily scale again. So for that, we used this method, downscaling model, developed by Welby and Dawson in 2007. And we used 2 scenarios, and because this model, the SDMS already includes 2 scenarios, and this also this global circulation model, the HAT-CM3, which is the English model. The scenario A2 means has medium level of emission, and the scenario B2 has a medium high emission. And what else? And then we did the bias correction, and this is the general formula for the bias correction. Okay, and then I think that we did a full analysis of trend. So here we have the flow chart for the trend analysis, and here for the variables, as we used them not daily, and we used then average monthly. What that means average daily, so monthly data. And here it's important to test the autocorrelation of the data series. So if there is autocorrelation, so then we proceed in this way, trying to find the trend-free and pre-rating. If there is no autocorrelation, so we can continue. But all the variables, the climatic variables, they could have autocorrelation. So then we proceed in this side, in this way. And then after filtering the data, so we tested the Mann-Kendall test, but also this is just for defining the significance. And then we defined the sense slope. So then we have the significance of the trend and the sense slope. That is the idea. And but also we defined the climate change signals and the extreme precipitation indices. And for those, we use typical methods. But for both scenarios, A2, B2, but also we tried to detect the monotonic trend in the frequency of occurrence and amount of precipitation on daily scale. Two extreme indices from the group of indices defined by this method expert team of climate change detection indices were used, and what that is maximum consecutive dry days and the percent and the 95 percentile. So we will see now the results about the trend and the signals of temperature and precipitation, which are the main variable for the evaporation. So here we can see the trend of minimum temperature, maximum temperature, and for the precipitation. As you can see here, for the minimum temperature, for the whole period, I mean from today up to end of this century, we have significant trend according to the Mann-Kendall test, and with a p-value of 0.05. And the same slope is here 0.001. Here now we can see for the maximum temperature. Again, we have the significant trend with the p-value of the same p-value. The same slope is higher, yes, definitely, for the maximum temperature. And also for the precipitation. And for the precipitation, we have declining. You see, I mean, with negative census slope of minus 0.016. About the signals here in the below, you can see for the temperature, minimum, maximum, and precipitation. So for the signals, we divided the whole period in 3 sub-periods. You can see here, the first period is for 2020 and 2040. The second period is from 2045 until 2070, and we have the rest period. Let's try to be focused on the precipitation, on changes in precipitation here. You see here we have for March, which is today is rainy season. We have all the time, for all the period, negative precipitation. So that means deficit precipitation. But for October, you know, which is already has passed. And for this area, October is dry season still, you know, it's not December yet. So, but in October, we can expect increase of precipitation, you know, and what does mean? That the seasons are changing. So that is the interesting thing that we found here. Now we will move to the next results. Again, here we have the table. No, you can see here the whole table, and for the trends, signals for minimum temperature, maximum precipitation, and evaporation. So just look at the evaporation now, for instance. No, this here we have the S, Z, and those are the Mann-Kendall statistic. Here the row one is the autocorrelation for lag 1, and that means that we have here the send slope. Here is written old send slope, new send slope, because this means because it's before old T means before the pre-whitening, and the new T is after the pre-whitening. So we should try to look then now at the new T values of sense slope. And what we obtained for the evaporation here, yes, we have significant strength, and this is the slope, and the sense slopes 0.010 for scenario A2, and we will see the similar situation for the scenario B2. The sense slope for evaporations, for instance, is higher in the previous, and we have significant trend. And also we did the trend analysis for monthly annual values of temperature, precipitation, and evaporation from the lake. So monthly values, then you can see here were for January, February, blah, 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 and up to December. And then here we have the maximum minimum values. For instance, when we are looking at the minimum temperature for January, we have the minimum value, yes, and but also for November, we are looking here the highest values. So the both are significant in terms of trend. January is significant and November significant. So, but also means that in November's, or we can see at yeah, maybe it's better to see at the maximum temperature. In October we are having higher the highest increase of temperature, you know, and the minimum might be in May, but which is not normal because the winter, the full winter is in July. So, but now already we are looking at May. But also I can describe about the evaporation, what happened in the evaporation. In November, yes, October is very rainy season, as you can see here. And then in November, yes, seems reasonable. In November, we have a deficit of, no, I mean low evaporation. And in February, yeah, can be, yes, high evaporation, which is summer. And then for each variables, we have this maximum sense slope and minimum sense slope. Okay, and the significance is the sign of significance here. For the evaporation, yes, we have significant trend for January, for February, March, April, May, no significant at all in July, and we have the negative trend for August, September, October, November, December, several months. About the trends of precipitation and evaporation for rainy season only. So that is December, January, February, March. And we have also the extreme values. And also here we have the values for here should be 25 years percentile. And we have here for the precipitation, if we compare the precipitation and evaporation for a long time period, we have a significant negative trend for the precipitation with p-value of, again, for the 0.05. Here the sense slope is -5. For the evaporation, we have increased evaporation all the time. And this has significant trend, and the sense slope, yes, is close, yeah, is 1.6. So that's the situation when we look at the seasonal values. And now here we have the extreme precipitation indices here in the lower part here. So you can see here Today, the extreme P indices is between 5 and 10 here, even less than 5. But yeah, but now it's already 2020, maybe it's 5. But in the future, at the end of the century, the consecutive dry days increase up to 60 days, 40 days, 30 days. And this is interesting. So that means that we can expect very long dry days without any rainfall. And then about the precipitation for 2020, 95%, the extreme amount of precipitation will decrease up to 20 millimeters per season at the end of century. Okay, it's a lot of decrease also. Finally, we have this figure. Here we plotted for long-term evaporation from the lake for 2 scenarios, A2, B2. And here, applying the adaptive forgetting factor, which is based on accumulative and moving average change of evaporation. So we found change points, and for instance, for scenario B2, so we found change point already for 2032 for a scenario A2 for 2039 here, which are going to be very soon. So that means that in these years we have change point, break point, or strong variation of precipitation or of evaporation. Sorry, but in general, today the average of evaporation from this lake is 1,700 millimeters per year. But in the future, at the end of the century, the average can be close to 200 millimeters higher or 300 millimeters higher. Today, the evaporation from the whole water balance constitute 95%. So almost all the discharge from the lake represent evaporation. And then the status of the lake is very close to the spills. And with this increase of evaporation, just the Titicaca Lake may turn into terminal lake. So what is my preliminary conclusion? The water evaporation from the open surface Titicaca Lake after 2030 may be accelerated, changing from today rate 1,700 millimeters up to more than 2,000 millimeters per year. For the medium-long scenario, which is A2, the signal, according to the signal, the increment of minimum temperature is expected to be 3.19 Celsius degrees, and the maximum temperature is expected to be 3 or almost 4 Celsius degrees at the end of this century. And these values, is similar to the previous values that were found by previous authors. Furthermore, for the same period and for the same scenario, A2, there is a significant negative trend of precipitation with the same slope of minus 5.20 millimeters per season. On the same time, there is a significant positive trend of evaporation with same slope of 2.40 millimeters per season. According to these dry days, consecutive dry days values, it may increase up to 60 consecutive days without no rains. Today, the lake status is very fragile, I can say, and that I explained it already. Then, taking account the high water evaporation after 2030, 30, which is very soon, after 10 years, the lake level may be declined or converted into terminal lake. Thank you very much for your attention. Hello, hello.
Oh,
Thank you.
Thank you very much, Dr. Ramiro. Any questions?
I have a question.
Yeah, please proceed.
Okay, so the warming is actually causing increased evaporation from the ocean. So my suggestion, if you're not getting enough rain, is that you don't have enough vegetation. Trees release terpenes which induce rain. So that's why, for example, the Amazon gets a lot of rain is because of all the trees there. So I don't really believe that your slope is, well, the graph you showed of the slope of the loss of precipitation looked a lot worse than your number actually said it was. But if you look at that graph, it doesn't really look like you have that much change of precipitation.
Yeah. Yes, we have here in the picture, yes, here.
Yeah, well, if you back up a couple.
Yes, this one.
No, back up one more slide.
Here.
That one. In the upper right-hand slide there, or picture.
Yes.
Well, you see the actual trend of that line is not that red slope. It's more flat than that. And your number for the change was really, really small, 0.01 something for the
Yes.
rate of change. It's really, really small.
Yeah, it's small. Yes, you're right. It's a minus 0.016.
Yeah. So your change in precipitation is not that much. I mean, yeah, it's a little bit decreased, but not that much to be so concerned about. What you should be more concerned about is loss of vegetation.
Yeah. Yeah, today also, maybe you are right. For the present period, for the present climate, they can say nobody found a significant trend. There is kind of trend, but there is no any significant. But in temperature, yes, we have in this region. We have warming, so that means the increase of temperature maximum, whatever we have. And then the evaporation here is a function of temperature, not precipitation, but we are trying to analyze combining with the precipitation, of course. But of course, I have to be honest that we need to analyze really what will happen with the precipitation in this area in the future. And but I can tell you that in the past, because I explained that there was found very low water levels in the Titicaca Lake in the past, and that was yes during the dry periods. And what means dry periods? Yes, warming periods that had been taking place and low precipitation. And also there was by modeling was estimated the reduction of precipitation for that periods. And then now, yes, the precipitation is quite variable. It's not stable. So maybe yes, difficult to analyze this variable. But the temperature maybe is much more.
Right. Well, thank you.
Thank you.
Thank you. Thank you. So next Next keynote presentation by Dr. Dave White from Climate Change Truth Inc., USA.
I can't share my screen yet.
Yeah.
Because it's me. Yeah, wait a minute, please.
Oh, okay, here we go.
This screen doesn't respond. It takes a long time, but I cannot skip. That's
Yes, we can see the screen.
okay.
It's us. No, wait a second. Let me go back up to the top. Sorry, I started at the wrong place here. Okay. All right, I will present you my published paper called Discovery Reduction in Photosynthesis Correlation to Atmospheric Carbon Dioxide Increase. I will show you how atmospheric carbon dioxide is not an emissions issue like we've been told, how sea level rise is not accelerating, and we have 8 medical doctors on our team and all the data, and I'll show you that as well. So first of all, every scientist should follow the data. And I'll show you global carbon atlas, why it's not our emissions, where we are, Mauna Loa CO2 growth rate, where we're going, what the photosynthesis issues are in the world, and the correct solution for atmospheric carbon dioxide with results, and the global warming potential model of the Intergovernmental Panel on Climate Change is false. So, use all the data, don't cherry pick. See what the data says, perform statistical analysis. All scientists know this. All models must be verified with actual data. You don't make a model and then publish it and say that it's true without verifying with actual data, and nobody should publish such a model. And this presentation is the result of following the data. And Nature Climate Change is a farce journal. The models of the Intergovernmental Panel on Climate Change are published there so that they can do circular referencing in their false reports. This is Global Carbon Atlas. Since 2006 in the United States, we have a 16% decrease in carbon dioxide. In Europe, since 1990, we have a 21% decrease of CO2. And this left graph here, this is what you will find online. You'll find the 2012 version of this that looks like the effect of the rise is due to emissions. And they don't want to show you the newer data because it takes away from what they say it is. Since 2014, we've had mostly flat emissions with a 3% drop last year. This is worldwide data. And this, as you can see, this is separating from the rise of CO2. So the correlation coefficient dropped to 0.64, and it's not cause and effect. I explained these statistics to Dr. Jim Scaia of IPCC Working Group 2, and he said, I agree. They know how to do cause and effect analysis, but they don't do it because it doesn't match their false agenda. So currently the correlation coefficient is 0.64. So we have had mostly lower fossil fuel emissions since 2014, but massive deforestation continues. And this is Mauna Loa growth rate. The rate of increase per year is right here, and it's around 2.5 or so now, heading to 3 parts per million per year. And this is the cycling, as we all know, for the global CO2. And minimum residence time used to be 5 years, and now it's 150 years. Most work is on carbon emissions reduction, and reforestation efforts are ongoing. And assumptions, if we keep the current carbon dioxide emissions around 35 billion metric tons. Decreases in carbon dioxide emissions will be offset by increases in population. Atmospheric carbon dioxide stays the same slope, and at 100 years, no more oil, so carbon dioxide emissions drop by 30%. And this next graph is what that looks like after I show you after I show you residence time. These are, I think, 19 published manuscripts, a total of more than 160 PhDs summarized in this published manuscript. The lowest residence time for atmospheric CO2 is 150 years. Now, if you looked at this as data, you would say the average of this data is probably around 220, 230, something like that. So the residence time is that long. And another way to look at residence time is there any signature or any effect from past events like the oil embargo in the 1970s, multiple recessions, the worldwide recession 2009, this COVID-19 pandemic? You can clearly see no effect of any of these events in this graph here. And if you have Netflix, watch the movie, I think it's called actually Kiss the Earth movie, and explains that even if we stopped all CO2 emissions, atmospheric CO2 will not come down. And this is what that graph looks like from those assumptions I said. The correlation of the CO2 emissions to atmospheric CO2 goes to 0 at year 2060 at 580 ppm. So in other words, at year 2060, anybody looking at emissions versus the CO2 rise will call us strange or deceived or something, back for scientists back here who believe that. So atmospheric CO2 never lowers by working on emissions. And this is Pearson's regression. And CO2 emissions correlate to a value of 363 parts per million, not the 415 that we're at. And this is another reason why it's not our emissions. 90% of the people live in Northern Hemisphere. This is a graph of population by degrees latitude. And you can see that most of the population lives in the Northern Hemisphere. If 90% of our emissions were driving Mauna Loa, this is what the graph should look like. But this is what the actual graph at Mauna Loa looks like. So this is another reason why it's not our emissions of CO2. And as a chemical engineer, we get taught 80-some tank models. The simplest one is like your kitchen sink. And the inputs are human CO2 and natural CO2. And the outputs are diffusion and photosynthesis. And, you know, we have the tank filling, we have the CO2 going up, but we also have the residence time increasing. Like I said, it used to be 5 years, and now it's 230 years because of massive worldwide non-sustainable deforestation. So if you came home, your kitchen sink has a higher water level and it's not draining, you need to shut off the input and fix the drain. Well, we can't shut off the input because we have all this natural carbon dioxide as well. So we need to fix the drain, and that's photosynthesis. So what photosynthesis could be 55 parts per million? This is atmospheric carbon dioxide by latitude. The atmospheric winds keep carbon dioxide consistent throughout all over the Earth. And this is courtesy of Dr. Peter Tans at Mauna Loa. Him and I put this data together and made these graphs. And this is the well-known Mauna Loa harmonic trend. You can see a strong trend, this yellow line at South America. So this is where the cause of this cycle is. So photosynthesis issues. City sprawl is 1 billion tons of lost CO2 consumption annually. The IPCC estimates 2 to 3 billion tons lost CO2 from biomass burning, which is way underestimated. deforestation of 30 million acres of the Amazon is 90 million tons of lost CO2 consumption. And more than 300 billion tons lost CO2 consumption annually from the Amazon rainforest switching. And this is our equilibrium paper. Northern Hemisphere forests consume only 2.6 billion tons per year of carbon dioxide. So there's this false idea out there that the reason why Mauna Loa or the world CO2 decreases when it's summertime in the Northern Hemisphere where all the people are is because it's a larger land mass and therefore more photosynthesis. Well, it's a larger land mass, but not more photosynthesis. There isn't any what you would call rainforests in the Northern Hemisphere. And then there's another published manuscript that shows all tropical forests in the Southern Hemisphere have switched to become oxygen consumers and carbon dioxide producers because of decay. And the same thing with the Amazon rainforest switched in the 1990s to be oxygen consumer and carbon dioxide producer. So we have a 5 times increase in emissions of carbon dioxide, mainly due to fossil fuel burning, but we have a 97% decrease in photosynthesis consumption. This is the reason, the main reason, and the only reason why carbon dioxide is increasing is we don't have enough consumption. And the World Economic Forum has rightly said we need to plant 1 trillion trees, which will in just 10 years drain the atmosphere quickly by increasing the consumption of CO2. We have 35 billion tons of human emissions, and the switch over the Amazon to an oxygen sink and carbon dioxide producer is 15 billion tons of unaccounted for carbon dioxide. And this is the photosynthesis issues. All this purple, even in the southeastern United States where they just mow down the trees, and up in here in Russia, Canada, Russia and China, in Canada here, South America here, in Africa, all over the world, massive worldwide deforestation. We used to have 390 billion tons of photosynthesis consumption, and we only have 8.6 billion tons left in the world. And this is the Amazon rainforest correlation to the rise of CO2 is a 0.99 cause and effect. And started in 1950, the 1957, the carbon dioxide started a current increase. In 1970s, trees and plants toppling over, burning of biomass causes 1 billion CO2 release annually, but the biggest issue is causing the other plants to grow too fast and toppling over and causing massive decay. So the 1990s change over to an oxygen sink and a carbon dioxide producer. And these are all facts from published papers. Like I said, we used to have around 390 billion tons of photosynthesis, but now we've lost most of it. We also have a 20% drop of Earth's oxygen production because of that. And this is what they do. This is just typically what's being done in the Amazon. And this is the oxygen loss. You can see it cycles just like the CO2 increase. So these two things are coupled together. And the correct solution for atmospheric CO2 is a moratorium on rainforest deforestation starting now. All nations need to put pressure on Brazil and South America to stop this. Plant native trees and shrubs all over the world. I have more than 5 billion native trees caused to be planted in the last 2.5 years. Stop deforestation in India and everywhere which is not sustainable. And these are the planting ideas, and this all government policy document is on the homepage of our site, cctruth.org. And this is the new paradigm. We do this, we get atmospheric carbon dioxide to 330 ppm by 2031. That quick when you work on photosynthesis. You can't do that working on emissions of CO2. Then also, there's been this lie out there that CO2 freezes in the mesosphere, which is not true. With the pressure in the mesosphere, the freezing temperature of CO2 is here, and this is the actual temperature in the mesosphere. And here's the results. So I presented in 2018, then I contacted the US embassies in South America, India, and China, and their environmental scientists saw the correct science in it. India stopped deforestation of their rainforest and are planting trees. China's planting trees, and Pakistan is planting trees. And we had flat CO2 in December a couple of years ago because of that, or last year, I should say. And then earlier this year, February, where it usually goes up 1.5 parts per million per month, was flat for the first time in 70 years with these trees being planted. And then that continued on in March, and then there was some problem with the analyzer at Mauna Loa, and when they fixed it, the difference here is exactly 1.5 parts per million. So whoever's in charge of this committed fraud and put in an offset, because like I say, the data was exactly 1.500 parts per million, this data here, then this data here, and it's still flat. And this is our state of Oregon sanctioned experiment. And we have NIST certified carbon dioxide sensors. Actually, they're calibrated within 3 parts per million, and 180,000 autos per day. The treat area in August was 28 parts per million lower than this non-treat area here. This is the treat area and the non-treat area. And then in October, it was still 20 parts per million. And we have a permit to do this, and I'll be doing this again in December for 2 weeks. I just yesterday sent the permit request. You have to put it in a month early, and doing this in December. And as long as this stays above the 3 parts per million increase that I showed you for the rate of rise, then this is the solution, because we can plant, instead of grass by roads, we can plant native shrubs and trees, and this will consume a lot of the CO2 from the vehicles. This is the first time this experiment has been done in the world ever. And then we have a article in the Rio Times that people are tweeting to these people, and Peru said they're going to stop this year, and we want everybody to tweet this to these leaders so that they stop. And then also I reviewed the Intergovernmental Panel on Climate Change, and their reports are science fiction. And on Facebook, you can connect to Climate Change Truth and watch and share the video that I made of my review. And review of SR 1.5 Chapter 2 mitigation is garbage. Their equilibrium statement had no references to any published manuscript. And like I said, we calculated the equilibrium is 8.6. And their only probability for their solution by lowering emissions for CO2 is 50 to 66%. And that is in that document. Would you take your car to a mechanic, or would you go to a doctor who said that they could fix you or the car 50 to 66% of the time? Of course not. And then working group 1, second order draft for AR6, the scientific consensus is 33%, not 97%. And the IPCC global warming potential is false, because it assumes equal concentration of greenhouse gases. CO2 concentration, for example, is around 412 parts per million, and methane is 1.5 parts per million. So these concentrations will never be the same. The other reason why it's false is because in this document in Annex V, I'll show you in a minute, I found published manuscripts before this one, or before their model, that clearly show methane is less of an effect of a greenhouse gas than carbon dioxide. And then sea level rise is 1.1 millimeter per year and not accelerating. The Jacobson Glacier in Greenland has grown for the third year in a row. And like I said, the residence time in a 2003 report, the IPCC said it was from 5 to 200 years. And working group 3, first order draft. As I said earlier, watch, I think it's called Kiss the Earth movie. And they use unscientific terms, highly or otherwise unlikely, and this kind of garbage. And I said earlier, the graph they say cause and effect for emissions has not been updated since 2012. And this is what I was talking about there, global warming potential. It's a false model, assumes equal greenhouse gases. This is Dr. Blasing's work in 2013 and shows CO2 as 1.94 watts per meter squared, methane is 0.5, nitrous is 0.2, and ozone is 0.4. And then the others are even very, very small. And this is what I said I found in Annex V of working group 1 second order draft for AR6. And these were all published well before their model. And these show the correct concentrations and then effect of the effect of global warming. And then I'll talk to you about sea level rise, tide gauges, and satellites. The future for New York City, not going to happen. Sea level rise is linear and not accelerating. The NOAA satellite, the Jason 3, has a minimum resolution of 25 millimeters. This is like using a yardstick with no gradations to put some unfamiliar object 20 feet away and then performing measurements. The data would not be reliable. And as I said, the Jacobson Glacier in Greenland has grown for the third year in a row. And these are tide gauges is 1.4 millimeters per year. Even the satellite data is 3.3 millimeters per year, but it's still linear and not accelerating. And this satellite is around 2.5 millimeters per year. The tide gauge distribution is throughout the world. And satellite systems, this is how they measure. And this satellite, like I said, it's linear and not accelerating. And this is some data about the different satellites and their tracking error and things like that. But this is tide gauges all over the world. And you can see some of them are decreasing, not increasing. And some are flat, some are slightly increasing. So this tells the truth about global sea rise right here. And then COVID-19, Operation Phoenix Rising. We have 8 medical doctors on our team, and all the data from the United States, Asia, and Europe, collected data daily and analyzed weekly. If you don't want to get COVID-19 or you want to have a much lower effect of COVID-19, take vitamins A, C, D, zinc, and tonic water. Tonic water has quinine, which is the active ingredient in hydroxychloroquine, which is the treatment for COVID-19. This is our first published manuscript. And in that, we show the recovery rate, at least for the United States data, which the data is the same all over the world. The recovery rate is 99.7%. This is better than the flu. The flu is worse than that. And the World Health Organization said COVID-19 may be transported by air, but we will show how it's not. And our second published manuscript shows that children especially don't get COVID-19 that much. And hydroxychloroquine and zinc are the cure, or the treatment for COVID-19. No vaccine is needed or wanted. Children pose zero risk to spread COVID-19. COVID-19 is not airborne transmitted. One nurse explained it like this: at a party, someone has glitter on their hair, by the end of the party, most everyone has glitter on them. And this is on the World Health Organization site. And what they did is they tested RNA in air samples in a COVID-19 ward in a hospital and found none, found 0 RNA in the air. And so that's one proof that it's not airborne transmitted. Homeless camps in the United States have no spike in cases. If there was a spike in cases in homeless camps, the media would have been all over it, but there hasn't been the whole time ever. And the recent riots in the United States have no spike in cases in them, especially before May 15th, where they weren't wearing masks. And Sweden and Denmark have similar infection rates. One closed down for COVID and the other did not. And the one who didn't close down is only like 1.3 times the infection rate of the other. So they're very close together. And random versus systematic, before mass, all the data was random. You get 2 here, 4 there, 6 there, 2 over there kind of thing. It wasn't like the classic systematic where you have, starts out and then it balloons out from an area, as you may have seen in documentaries before. So an airborne infection would have systematic data. COVID-19 without mass is random data. And then COVID-19 treatment is hydroxychloroquine, 79 studies and 46 peer-reviewed. And this is the link here. Countries which use hydroxychloroquine have much lower death rates. Excuse me. And children pose 0 risk to spread COVID-19. And all of this is on the COVID-19 page of leftmedialies.com. And then this is our 4th publication. For the United States, we show that the Centers for Disease Control broke federal law when they threw away their pandemic book that wouldn't have let them use all these presumptive cases and presumptive deaths. And we only have less than 9,700 deaths in the United States due to COVID-19. Not the 200, now it's like 220,000 that they're lying about. And masks and social distancing are lies. This study, the CDC found overwhelming majority of people getting COVID-19 wore masks. Well, most people are wearing cloth masks, and cloth masks are worthless for COVID because the molecule is less than a micron, and a cloth mask has pores that are 200 to 300 microns. So this is a summary. And acknowledgements, International Journal of Chemical Engineering and Journal of Environmental Science and Development. Our manuscript is dual peer reviewed and published this conference. And thank you for your kind attention, and I'll take questions. Any questions?
Hello.
Yes.
Yeah. Thank you very much, Dr. Dave.
Yes, you're welcome.
Yeah, any queries? Yeah, shall I continue with the next present?
Yeah, that's fine. You can switch off my screen sharing.
Okay. Okay, next is poster presentation by Dr. Evita Stord from Latvian Institute of Aquatic Ecology, Latvia. Yes, we are able to see your screen.
And you heard me also, yes?
Yes.
Okay. Thanks for introduction. As introduced me, my name is Evita, and I am a researcher from of Latvian Institute of Aquatic Ecology, and I will present you today my first results of my postdoc grant work, and this time topic about environmental health assessment of the Gulf of Riga using biomarkers and amphipod monoprey affinis. In my research work, I am interested to use environmental health assessment with new tools and approaches to identify emerging risk in nature are based on early warning systems technology. And I think detecting biological effects of contaminations on organisms are very important nowadays. And it is not enough detect pollutant concentrations on environment. Integrated ecotoxicological approaches has been used to determine and characterize environmental toxicity risk and ecological impact that contaminants cause on the healthy generation of aquatic food web populations. And in this case, we try detecting the case of potential contaminant stressors, and understanding of chemicals modes of toxicity can be linked with diagnostic markers of aquatic animals physiology to help understand the health status of aquatic organisms in situ. And the aim of the study was to assess environmental quality in the Gulf of Riga by using selected biomarkers as embryo malformation frequency, acetylcholinesterase, catalase, gluten S transferase, measured in amphipods, monoprey affinis, to represent different types of biological responses reacting to different stressors. And what kind of methods we use? The first, we want to use a biomarker of reproductive disorders. We need to collect 15 gravid females per each station, as recommended a Swedish institute. And the marsupium of the gravid females of monoprey affinis was analyzed under a stereo microscope to identify different embryo variables. And I need to mention that the monoprey affinis reproductive cycle for this analysis better is February, when embryo is developed stage in middle 4 to 6 stage. But our case, we could organize sampling only in March, and but in this case, most of females were released juveniles, or embryo stage was most of them were detected at last stage 8 to juveniles. But when we collect 8 years ago in March, that this embryo developed was not so high. That means maybe climate changes also impact this amphipod development. And second, we want to compare these reproductive disorders with enzymatic biomarkers. But in this case, I need also to mention that collected samples were lost due to broken freezer, minus 18 degrees. And but we collect new samples in August and detected enzymatic biomarkers, acetylcholinesterase, catalase, and GAST activity in monoprey affinis, and conducted according to methods with the modification for microplate. And what kind of results we detected? Monoprey affinis embryo malformation results show that 67% of sites with high sediment quality colored blue, and 33% of sites can be classified as good, green colored in Gulf of Riga. And although the guidelines recommends to analyze at least 15 gravid females of monopriaphenis, due to sampling time in March, it was possible to carry it out only in 45 stations. I mean, only 4 stations from 10. And reproductive quality showed higher embryo aberrations than embryo with RS development. That means green also undifferentiated eggs in the stations 114 and 11. Also in 162B. And also did or partly did broods in the stations. These stations is where Gulf of Riga is start with the Baltic Sea, Irbes Strait. And based on the threshold value of the frequency of malformed embryos and frequency of females carrying more than one malformed embryos, only in the 22% of the station sediment status were found to be above the good quality, above the gas boundaries and classified as bad quality. And that means that from 10 stations, 2 of them is more of stations we could classify it as good quality by this biomarker reproductive disorders. And results of enzymatic biomarkers, the significant higher catalyze activity was found in the estuary of River Daugava, that means station 101A, compare other stations. And lower glutathione S transferase activity in monopriaphins were found in the stations 167. That is estuary of River Lielupe. And while significantly higher enzyme activity were detected in the eastern part of Gulf of Riga, that means this station. And acetylcholine esterase activity in monopriaphis didn't show significant differences between most of the stations, except one station where the enzyme value were detected highest. And based on the integrated biomarker index, EBR, the highest impact was detected in station bigger river estuary Daugava, and also eastern part of Gulf of Riga. And what we could conclude by this work, based on the results of reproductive disorders analyzed in March, sediment status can be classified as bad only in the 2 stations where the higher embryo aberrations were detected. However, results would be expected slightly different in the stations if the recommended number of gravid females had been collected. And biomarker results from the August sampling showed high enzymatic response in the station, River Daugava, and eastern part of the Gulf. In general, our results indicate good or moderate states of environment health on the Gulf of Riga ecosystem. But also I want to mention that this was pilot experiments with the biomarkers first time, because we start introducing these methods in our laboratory. And I hope this result this is the first result that we could start next year, use next year to compare. Also, maybe we collect in November also this species, and then could see how high this enzymatic activities in antipodes are. And yes, how I mentioned that this work is supported by my postdoc grant. Maybe you have some questions?
Hello. Hello, can you hear me?
Yes.
Yeah. Have you done with your presentation?
Yes.
Yes. Any queries? Shall I continue with the next presentation?
May I put a question? Can you hear me?
Yes.
Yes, yes.
Yes. My name is Rosanna Nastro from University Partenope of Naples, Italy. I have just one question. Have you carried out some other ecological tests, ecotoxicological tests on other organisms, just to test if just to verify if your hypothesis is correct? What I mean is, in most part of cases, when we carry out a survey on in the ecotoxicological field, we consider a battery of test organisms. So we take, I don't know, a crustacean or bacteria, algae, and so on. Have you considered to carry out a similar test using multiple species, just to confirm what you observed?
Yes, in our lab we use algae test, also Daphnia, Magna, and amphipods as test species. But in this part of job, I want to comparison this malformed eggs development stage with the biomarkers, because these disorders. This is very hard to detect. You need 15 animals, gravid animals, and you need looking all this eggs. It's one female have more than hundreds. Then you need look. This method is very not hard, but very also hard, because you need looking in microscope. But I want to compare them with another biomarkers. Maybe I could use these biomarkers, enzymatic activities, and then I could say that in this environment is polluted. They show effect on this species.
I see. So it is just to correlate the biomarkers you used to the percentage of alteration in the embryos as well. But okay, it was just the aim. It is your aim. Your aim was
but
just to verify
I couldn't do this in this time.
Because, okay, thank you. Thanks a lot.
Thanks. Sara?
I think I'm next, but I don't know if I can start.
You could share your screen.
Yeah. Can I start then? Well, I'm gonna start. So, hello everyone. First of all, I would like to compliment everyone virtually present today. My name is Catarina. I'm from Portugal, representing the University of Porto. And today I will present you my poster that is entitled Novel Ecosystems Towards Climate Change Adaptation and Resilience in Cities. This work was inspired by a recent publication in the journal Landscape Ecology. You can go see if you want, or I can send you later the publication. I will start by introducing this subject, the subject addressed in this work, which is novel ecosystems. I don't know if you are familiar with the concept. So, over the past years, human actions and movement, technological advances and global trade have emerged as drivers of change, allowing the spread and introduction of species into different regions. So these rapid transformations have contributed to a biotic globalization and consequently to the reconfiguration of ecosystem processes and patterns. So as a result, combinations of native and exotic organisms that may never have coexisted before are emerging throughout the globe, forming what is being designated as novel ecosystems. Due to anthropogenic factors and by the addition or loss of species, they are in fact unprecedented. So, in the urban context, the effects of human agency and Anthropocene can be more pronounced since cities are artificial and deeply constructed systems where human population is more concentrated. And this way, as a whole, urban areas have been usually considered novel in relation with their non-urban counterparts. So, through a systematic review, the aim of this work was to understand the novel ecosystem concept and specifically answer to 3 research questions. They are how the novel ecosystem concept has evolved through time. This is the first question. What has been the main focus and trends of novel ecosystem research? And finally, what are the main opportunities of novel urban ecosystems for future planning and design of cities? This systematic review followed a strict protocol by Collaboration for Environmental Evidence. I can show you also the reference for that here. First, a literature search using the keyword novel ecosystems and novel urban ecosystems was performed in several databases, such as Web of Science, the Scopus, Science Direct, and also using Google Scholar. In this step, we have collected 548 unique records. We have excluded the duplicated using HandNote, the software. Then we have applied inclusion and exclusion criteria in order to identify only relevant records for this study. First, we analyzed the title and abstract, and then the full text. We excluded records that clearly departed from this concept or were from unrelated research areas, for instance, medicine or computer science, for instance. We also excluded records unable to access the full text and records that were not sufficiently focused on the concept. So for a record to be considered relevant, it had to discuss and explore the concept, contribute to a better understanding of what novel ecosystems are, or provide case studies or examples of novelty around the globe. We end up with 255 relevant records that were published between 1997 and 2018. So regarding the first research question, how do novel ecosystems evolve through time? Here you can see this graph showing the evolution of the concept in the publications. We have learned from the final database that this concept is very recent, but yet over the 23 years that passed, a considerable amount of research has been produced so far. It was first used, the concept was first used in 1997, as I said before, but only later in 2006, the first definition of the concept emerged in a seminal paper by Richard Oz that put the concept in the spotlight. After 2006, as the concept evolved and expired interest among researchers, the number of records increased noticeably every year, as you can see for the graph. And the concept was applied to the urban domain in 2010. But the term novel urban ecosystem was only used for the first time in 2011 by the researcher Ingo Kovarik. In 2013, a comprehensive book emerged called Novel Ecosystems Intervening in the New World Order. As a result of a workshop that gathered 50 researchers from several parts of the world and from different research backgrounds that were gathered just to discuss this concept. As you can see, 2013 was clearly the year with a higher number of records so far. Nonetheless, the interest on the concept persisted in the following years to date. Publications increased again recently in 2018, particularly regarding the urban domain. To answer to the second research question, which was what has been the main focus and trends of novel ecosystems research, we have analyzed the data according to three aspects. What were the taxonomic groups focus, what were the ecosystem types, and what was the geographical area of focus. And we've learned that novel ecosystem research has been mainly focused on multiple taxonomic groups, that is both plants and animals together, but also solely on plants. We have also learned that novel ecosystems research has been mainly focused on terrestrial ecosystems. And regarding the geographical area, we have learned that research has been mainly conducted on North America, specifically in the United States and also in Puerto Rico. But we can also say that recently it has been increasing the number of publications in Europe, specifically regarding the urban domain. To answer to the final research question, what are the main opportunities of this concept for future planning and design of cities, specifically for climate change? So knowledge gathered in this research allow it to reflect about the role that the novel urban ecosystem will likely play promoting solutions to sustainable and resilient urban environments. Regarding these four different aspects: contact with nature, ecosystem service delivery, climate change adaptation, and also cities as laboratories, and I will explain. Regarding this first one, once the majority of the world's population lives now in urban settlements, people are increasingly experiencing nature in cities. So novel urban ecosystems can provide opportunities to contact with nature and at the same time raise public awareness about this concept. In AC, the contact with nature benefits simultaneously the urban biodiversity. First, because it can instill in the population more environmental responsibility and orientation. And in turn, it can also have positive feedbacks for conservation. Regarding the ecosystem service delivery, as we all know, urbanization and population growth continue to be demographic trends. And for that reason, it will be increasingly important to promote ecosystem services that benefit human well-being. Novel urban ecosystems may provide recreational opportunities, cultural and aesthetic benefits, and even new ecosystem services that we still do not know about. These systems could be designed, managed, and monitored to improve the delivery of services and also to mitigate potential disservices. Regarding the climate change adaptation, novel urban ecosystems can be deliberately integrated into urban planning and designed to play a key role in creating more resilient cities and in adapting to future climates. Novel assemblage of species are already living and thriving in extreme conditions of cities, suggesting that they may be pre-adapted to current urban climates. And for that reason, they can offer models to support climate change adaptation. We can say also that if well-managed novelty, ecological novelty, may harbor opportunistic organisms and biodiversity and increase resilience to face climate change. Finally, cities as laboratories. This means that cities can function as living laboratories capable not only of simulating scenarios of future change, as they already do, but also for testing possible strategies and solutions. Novel urban ecosystems can represent an opportunity for experimentation that will inform future actions and provide important tools to face uncertain scenarios of change. Finally, I would like to show you the list of references that I use. I can share this poster if anyone is interested. And you can also reach out to talk to me if you are interested. I will leave here my email. And many thanks for your attention.
Yeah, thank you very much, Katerina. It was a very nice presentation from you. And any questions? Yeah, can I move to the next presentation?
Sure.
Yeah, next presentation by Dr. Gajanan S. Bhatt from University of Georgia, USA. Dr. Gajana, can you please unmute and share your screen?
Can I share the screen now?
Yes, you can share the screen now.
Let me see. All right. Okay.
Small announcement. A few of the speakers are not able to join today. They'll be joining tomorrow. If anyone speakers from day 2 are interested to present today, Kindly message me or mail me or inform me on chat.
Uh, okay. You can't see my screen, right?
Yes, we can see.
No, can you see my PowerPoint?
No, we can. We are not able to see.
Okay.
Click on the screen.
Okay. Just give me a second because I don't use the GoToMeeting generally. I use Zoom and how do I share the screen here? Where do I go?
You can see 4 buttons in the middle: mic, camera, and next to that screen. Click on that.
Oh, okay. Yep. Okay. Okay. Oh, it's not allowing me to share the screen, so just 1 second.
Okay, no problem.
Accessibility. It does not allow me to share the screen, so ask for system preferences. I can definitely see the button, but it does not allow me to share.
Okay, just click on that. You can see the share screen. The third one, the third button.
Yeah, no, I see it, but it says it does not allow me. So I'm trying to see if there is any setting I need to change, firewall
Okay.
or something. The reason is needs to use accessibility features, include keyword, mouse control, and allow access. Okay, system preferences. Pictures, services, accessibility. Okay, turn voice. I'm not sure what is the problem here.
Okay. Send me your PowerPoint slides
Okay.
with my email.
Let me do that right away. So that may be better. Charles reply. Desktop. It's on its way. I just sent it.
Okay. May I know which email you have sent?
The one Sharon Charles, coastalresearch@gmail.com.
Yes, yes. I'm just downloading it.
I guess that's the email you used to send the link.
Yeah. Okay, I'm just trying to share the screen.
Uh, are you able to open the PowerPoint? All right, that's good. Thank you. Well, it looks like, Sarah, you have to help me in moving to the next slide. I don't have any control, I guess. Um, Once again, thank you all for this opportunity, and sorry for the delay. What I would like to talk about is some of the research that we have been doing in the past few years and continuing to address the textile waste issue, mainly to produce value-added products from the textile waste. And if you look at because it is a continuing problem, and how two things. Number one, how we can reduce the waste that's going in, and then also make useful products. Majority of the textile waste is thrown into the landfill, and we know that it is composed of multiple materials, and even in the landfill, number one, it occupies a lot of landfill space. More than that, it also creates further pollution in the landfill as the material stays longer. In fact, textile waste is considered the second largest polluter after oil industry. Today, about 100 million tons per year of textile waste is produced around the world. In fact, about 10 to 20% of the textile waste is produced even in the manufacturing process. That is starting from fiber to yarn to fabric, and then the apparel products. This is a significant amount of the fiber textile waste, and then after use, a lot more waste are produced. Today, in fact, with the fast fashion today, people tend to use textiles for a much shorter period of time because fashion is changing. You don't use the same, and after a while it goes somewhere. Maybe sometimes it has a second user, but after that it ends up in waste. And fast fashion is also contributing, and it is expected that in the next 10 years, the waste produced will increase by another 60%. So if you go to the next slide, thank you. This gives a picture of where the waste is produced. Developed countries where the economy is better and we use more fabrics for shorter period of time and switch to new fashionable materials. I think the waste is increasing. So that's why the 2/3 of the waste is produced by 1/3 of the, less than 1/3 of the population, that is US and Western Europe. The waste consists of, again, typically the composition of the textiles being used. Polyester is, contributes to more than half. And then natural fibers like cotton, jute, wool, and also polypropylene, nylon, etc. So this is the typical composition. And I think it is important, especially in the developing countries where the consumption and waste generated is more, we look into how we can reduce the waste discarded and also what we can do to improve the life of these materials and create new alternative products. The next slide. The US, again, re-emphasized the fact produces, yeah, the next one. Yeah, thank you. 25 billion pounds, which corresponds to about 82 pounds per consumer, and of which 85% is going to landfill, only 15% is recycled, reused, etc. Now, this looks like a large number. Now, obviously, those in the US or even other parts think, what are you really, wasting 82 pounds? Well, it includes not just the textiles that we are wearing, the fabrics, but includes all the textile products in the house, from the furnishing to carpets, all these. So when you account for all these and calculate, it corresponds to about 80 plus pounds per consumer. And I think that's why it is a really big problem that needs to be addressed. So the next slide. What do we do with this one? I think if obviously the choice is use the textile products longer, but with the changing situation, it's not going to be easy. If we can reuse or find another use, it's better. There are definitely movements coming up, especially they call recycle, sometimes upcycle, because the value of the recycled products is high enough. And then also try to produce alternate products. One has to be aware that proper recycling can reduce the number one, fiber production, either even natural fibers by the cotton production can be reduced. Help reduce the other environmental effect, because when you talk about reducing the production, it leads to savings in the water consumption, fertilizer, manure, etc. That can contribute to the environment. Also, it has been shown by some researchers that if you are trying to reuse or recycle fibers, the energy consumption can also be reduced. So that's another contributor to the positive aspects of the environment. And it's been shown that for cotton, 2.5% of the energy is required if you use recycled fiber compared to the new virgin fiber. So when we were looking at these, one of the ideas that came was, can we make these fibers, convert these fibers into insulation products? Next slide, why insulation products? The need for insulation is huge. World insulation market is expected again to be about $100 billion in the next 5 years. Insulation is used in a lot of places, in the buildings, in the automotives, in the cars, buses, or any of those. They use a lot of insulation, and even in appliances. If you whether it's a refrigerator or the washing machine or this, to reduce the noise, there is quite a bit of insulation material used. In the buildings, it has been shown that by proper insulation, you can save significant amount of energy for heating, cooling, air conditioning, etc. And it's been shown that with good insulation, 65% of the energy consumed can be reduced. That's for the thermal part. And then also acoustic, because noise pollution. Again, if you are going in the car, you don't want to hear the noise from outside, and not necessarily the outsiders have to hear the loud music if you are playing or something like that. And I think good insulation makes sense. And that's why we looked at this use of these textile waste, recycled textiles into insulation products. The next slide, the insulation materials, if you look at it, obviously there are insulation materials being used in all these cases. Most of them use fiberglass or some mineral wool, and then plastics. They have some disadvantages. Of course, glass fiber is cheap, but then in case of fracture or failure, then sharp glass fiber tips can be dangerous. Now, synthetics, like general plastics, have adverse effect in the environment. Glass also have the carcinogenic effect. Not necessarily when it is inside covered, but when it is being disposed and handled, etc. So in this context, especially natural fibers, and then also the recycled materials that are abundantly available, can be sustainable alternatives. Obviously, because of this positive environmental effect, because you are using more of the naturally produced material, which can be handled and disposed of easily. And then also there is a reduction in any of the health hazard. So for this, we looked at the use of recycled fibers as non-woven materials. The next slide, why non-wovens approach? Well, obviously, I have been conducting research in the area of non-wovens for 3 decades, and that's a nice fit for me. But more importantly, non-wovens are specialty textiles which are easier to fabricate, the cheapest way of producing fibers, can handle variety of fibers, blends, various sizes of fibers, unlike traditional textile production of weaving and knitting. And these non-wovens, essentially these are mats of fibers or felts, where you take the fibers without going through the production of yarn, unlike in the traditional processes, and put the fibers in the mat form and bind them together. So these non-woven mats or felts conform to shapes, which means if you are producing an insulation product, molded product, either as non-woven or molded to shape, can be used in various places, like especially in automobile, in the door, other parts, or in the appliance around the products, etc. It can be molded into shape, or as a non-woven felt itself can be put as a cover. So this makes it a cost-effective approach, and even the process is simple, and I think it makes it more valuable. It's a unique construction approach, fairly simple, and for a process as simple, it is you can change the properties. You can achieve a good balance of mechanical and insulation properties, thermal, acoustic as well. And you can really engineer the structure, vary the thickness and properties, so forth. We'll talk about it. And so you can achieve improved acoustics. And also, these are fairly lightweight, so reduce the weight. Now, it is important, the weight reduction, especially when we talk about automotives. The next slide, we talk about the automotives where non-wovens are used. It's been shown that non-wovens are used significantly. About 33 square meters on the average are used in the automotives for different places, for the linings. Some you see, like in the trunk covers, linings, roof linings, etc., under the seat, and also sometimes behind the seat covered part, in the door panels, etc. A lot of places, non-wovens or non-woven products are used. And here it is significant amount in the normal car, as you can see, and it's a huge volume. And again, as I mentioned earlier, a lot of the material used today is fiberglass and polypropylene, and I think it makes sense if we can significantly shift some of those molded composites and also increase the other part where currently, needle punch non-wovens are used. If we can switch to some of the recycled products. The other thing also is that obviously the worldwide market is shown to be 50, with automobiles continuing to increase. It's billions of dollars, billion in the market. So the next slide. Again, what is required in these products? Obviously, the moldability is important because if you look at the car, for example, the shapes change, the contours change, and if you have a product that can be molded to all those shapes very easily, should have sufficient mechanical properties, which is minimum, strength, tensile, tear, abrasion resistance, and durability. In addition to that, sustainability is important. In fact, about 2 decades ago, European Union had a mandate that 95% of the products used in automobile should be either recycled or disposed of in a safe way, such as with the biodegradability. So I think considering all that into consideration, we need to design products either recyclable or biodegradable. So that's why sustainability is important, and that's another thing into consideration. In that context, the next slide, the natural fibers definitely have an advantage. When I talk about natural fibers, cotton is one, but flax, kenaf, linen, and depending on the area, which part of the world, local fibers, even banana, jute, all these could be part of it. So obviously, natural fibers in general have natural feel and more acceptance by humans, the users. Natural fibers also have a good thermal and acoustic insulation because of the unique structure of these fibers. They are lightweight, flexible, and you can achieve decent strength. Now, when natural fibers, with some combination, are converted into non-wovens, you also have good Z direction properties. That is, especially if you are talking about thick fiber mat, you don't have to worry about delamination like in composites. And unlike in glass fibers, you don't have to worry about sharp edges during breakage. More important, natural fibers are biodegradable. which means we can dispose of after its use. Now, remember, this should last. It has to be durable, and they are during the use of the car, maybe 15, 20 years. Same with the appliances. In the case of buildings, as long as the buildings last, they are durable, but once they are disposed of, they are biodegradable. More important, these come from renewable resources. Majority of these are plant-based. Now, of course, you could also use wool and others which are animal-based, but these are all renewable. And when you're talking about plant, they use renewable energy. I mean, it's not like fossil fuels. It is from a plant which uses solar energy, in addition to obviously carbon capture. So our first work was to use the recycled denim. We did get help from a company which took recycled denim and shredded into fibers. So in the left side, you will see the bundle of recycled denim fibers. Now, the way we use the product, we needed a binder fiber, which is not a characteristic of natural fibers. And on the right side, we used a small amount of, again, plant-based thermoplastic fiber. So these are again from renewable resources and have been shown to be biodegradable. The next slide shows the DSC, differential scanning calorimetry scan of the binder fiber, one of the binder fibers, Sorona, produced by DuPont, pioneer in synthetic fibers. And it shows a melting point about 250 degrees Celsius, which is slightly higher for this purpose. And it's basically there are two peaks, heating and cooling. The top one shows the crystallization peak while cooling, but the bottom one shows the melting. Now, for producing molded products, you don't need to completely melt the fibers, but get close to that. So the next slide shows the process. And what here, this is a laboratory card in our lab that we used. It's a small card to make samples, but carding is a process which is used in the industry, textile industry, which has been used for 400 plus years, which is used to take fibers like cotton or blends and convert them into yarn. In this case, what we do is we have the fibers fed into the left side, and on the right side, on the drum, it wraps a sheet of fibers and produces a mat. This process is used in the nonwovens industry today. This is a small card that we used in our lab, but in the industry, these are about 1 to 2 meter wide. So you can produce very wide mats of the fibers and fiber blends of different thickness. Why I'm talking about it is because this machine, in the lab scale machine, is something similar to, it's like a pilot line, similar to what is practiced in the industry. What we show here translates into actual production very easily. So then the next slide, we took the carded web sheet of fibers and pressed it between two hot plates here. So this is a Carver hot press. Again, these hot presses are used in the composites industry quite a bit. So well-mixed fiber is pressed between the two hot plates under pressure to produce compact molded structures. Now, as I did mention, in some cases, you don't have to create molded. You can take these webs of fibers and needle punch them and produce very loose mat-like structure which can be used. And those are the kind of things that you see in the trunk liners in the car and so forth. So these mixed fiber webs were molded in our case so that this can be used in insulation where we don't see it, like in the inside the door panels and different parts of the car, or in the building, or in the appliances. The next slide shows few pictures of different samples of composite panels. Again, different combination of the denim and binder fiber. Now again, remember, denim is essentially all cotton, and binder fiber is again produced from the renewable resource, plant-based fiber. So we used various percentage of fiber to see whether it makes a difference. Number one, in the mechanical properties and also in the insulation properties of the products produced. Also, we used multiple layers. And the next slide shows some of the properties of the composite products. This shows the couple of instruments we used for composites evaluation. Obviously, we looked at different properties: air permeability, density, thickness, mechanical properties, etc., which is commonly used in textile and composite industry. The two pictures on the right side, on the top one shows the impedance tube, which is used for acoustic property measurements. In this case, what it done is the sample is in the middle, and then you have a sound generator on one side, and then transmission measurement, one on the left side, and then two on the other side of the sample. So that way we can determine the sound reflected as well as sound transmitted. So that way we can measure how effective are these insulating materials in different combination of fibers as well as different molding conditions. The picture on the right bottom shows the instrument for thermal insulation material. Again, the heat generated and how the heat is transmitted flows through the composite panel or the mat can be measured by these two equipments. The next one shows the picture of SEM photograph of a couple of, the next slide, panels. Now, in this case, the one on the left is a slightly low temperature, on the right, high temperature. And if you go to very high temperature, now the key thing is these make really compact panels, stiff. And if you go too high temperature, it can degrade some fibers as well, as we saw in the right side picture. That's not what we want to achieve. The next slide shows the change in the thickness and the air permeability. Obviously, if you increase the binder fiber composition as well as the temperature, you reduce the thickness of the material, because two things. Number one, the binder fiber melts and creates the bond between the cotton fiber, and that helps to pack the fibers very well. So that's how thickness goes up. And also, in general, overall, because we are producing a very compact structure here, the air permeability goes down because it becomes less porous and air cannot go through it, which is an indication that you are closing the pores of this web in the composite panel. So the next slide shows the overall measurement of the transmission. This captures the summary of the transmission loss measurement for multiple samples here. So what we see is that the transmission loss increases obviously with the areal density and the thickness. Obviously, if you have thicker the material, more material to block the sound and the density, the transmission loss increases. That means most of the sound is blocked. Now, the permeability is another thing. Again, if you have, the one which shows going down is that if the permeability is lower, again, you have increasing loss as well. Now, in the previous slide, I showed the thickness and permeability. And what it means is that by controlling the binder composition as well as the molding temperature. We can control the thickness and permeability or the area density or bulk density of the material and achieve the desired sound loss for a particular application. So it allows one to engineer the structure for the desired properties in a fairly easy way. The next slide, we also looked at another binder fiber called PLA. PLA is a polylactic acid, which is a fiber produced from cornstarch. So in this case, we did switch from the Sorona, another DuPont's binder fiber, that was also from the plant-based fiber. Now PLA produced from cornstarch, like a synthetic fiber, has a lower melting temperature. So that would allow us to produce the composite panels at a lower temperature without damaging the cotton. So in this case also, we looked at the binder concentration, bonding temperature, time, pressure, etc. The next slide shows the different combination we used. Again, in this case, with 60 and 70% recycled fiber, we looked at 40 and 30% PLA, and then we looked at different combination of layers of these webs, bonding temperature, pressure, and time. Now, one thing to draw your attention is the bonding temperature in these cases is lower than 200 degrees Celsius. And in the case of Sorona, it was 230 plus because the melting temperature of the other binder fiber was very high. In this case, the melting temperature was much lower, and that allowed us to use lower bonding temperature and produce molded products, which will prevent degradation of cotton. Because cotton, if it's you exposed to 200 degrees Celsius or higher for a longer period of time, can degrade, and one can even smell. It is like burning paper smell, and you don't want that, because if that is the case in the insulation product, over a period of time, there may be volatile gases evolved as well. So that's why we switched to PLA. The next slide shows the effect of molding temperature on these products. Again, with also different binder fiber composition. Now, if you look at the breaking energy, that's the strength of that. Obviously, higher binder percentage, 40% PLA gives slightly higher breaking energy in these cases with the different molding temperature. Now, again, going to very high molding temperature does not help. We don't have to go to 200, 180 and 190, small difference. So at 180 degrees C molding temperature, fairly strong. When I say here strong, it is it's combination of strength and elongation. The breaking fracture energy to break is higher. So the next slide shows the effect of molding temperature, molding pressure. Again, in this case, we used, for a particular temperature. When you looked at the pressure, obviously higher the pressure, it is better. Again, about 3-ton intermediate pressure, you get the optimum breaking energy. So this is kind of optimizing the conditions to produce the good quality composite panels. The next slide shows again the effect of molding time. Again, we don't have to go to very high time. So in about 2 minutes, you can get optimum breaking energy. So this indicated that in a short molding cycle, without going to very high temperature, using PLA, one can produce good molded products. Having looked at this, again, I didn't, I don't have the insulation data here, but in the previous work we had looked at that. We decided to move to another set, because yes, with the denim, we saw good performance. And while talking to an industry, they were saying that, hey, in our production, we are getting about 10% of the fabric waste. Can you do something? So this was a company producing military uniforms and said, well, let's look at it. And the next slide shows the whole schematic of what we did. Um, the next slide, please. So we took textile fabric trims and tried to composite panels. So again, as I said, trim waste from a military uniform manufacturer. We got help from a company which helped taking the trims, cut pieces of the fabric and breaking it open into not individual fibers, but bundles of fibers and yarn pieces and etc. So we could take that and then again mix small amount of PLA like we did just, I talked to you just before, and then go through the carding process, the one same laboratory card that I showed you earlier. So we could make from the mixture of these trim waste and about 15% binder card. And then we took those carded, and in this case, with another industrial partner, needled them into felt. I did talk about needling. So needling is when you have a loose fiber mat, you take needles and tack them. So that creates the bonding, mechanical bonding or between, which makes as entanglement between fibers, which produces a felt. As you can see on the right side, felt. Actually, a felt like that could be used, like in the trunk liner and so forth. And then also we molded them and looked at the thermal and acoustic properties of this. On the left side is the thermal conductivity, which shows that, again, which is affected by the density and thickness. Again, here I'm going back. In these two pictures, we are capturing a lot of data, effect of the permeability, thickness, area density on insulation, and on the left side on the thermal, on the right side on the acoustic. So if you go higher on the right side, that means noise reduction coefficient is higher. NRC is noise reduction coefficient, which means it is a better insulator. And on the left side, again, it is the thermal conductivity is lower, means lower the value, better insulator. So by looking at, well, two things to summarize. Obviously, you can achieve, produce good insulation properties, and also you can engineer and control them by the controlling the thickness and the area density by how much fiber you want to use, and also what conditions are used in molding. So the next slide to summarize. In the next slide, please. In summary, we successfully demonstrated that textile waste can be recycled. We looked at recycled denim as well as industrial waste from a military uniform manufacturer. Very good thermal insulation. In fact, average thermal resistance was, it is in the units that is typically used. The key thing is these values were much better than the fiberglass composite that is reported for commercially used insulation products. So that means there is a good scope for increasing the now thermal insulation further. We haven't optimized completely, but at least based on that, it's not just encouraging, very promising, and further by changing the density and bulkiness, etc., we can improve. Acoustic insulation of updated denim we have measured, but in the recycled fabric waste we are yet to measure. So further optimization will continue. And again, I want to bring the point that approaches used are something which can be commercially adapted very easily because these used commercially used processes. Next slide, the advantages of such a product. Again, sustainably, way to use the textile, because we use approaches, the processes, which are again environmentally safe, easy, less energy consuming, and so we have not much strain on the environment, lower energy consumption. Obviously, reducing the landfills space as well as the cost of landfilling, I think is advantage. Then again, virgin fibrous materials from natural resources, reduction in greenhouse gas, pollution, all these things are the advantage. And also, by using such insulation products, the health of the human can be improved by using an alternate product like this. And I think it is really good for the new circular economy. In the next slide, I just want to acknowledge some of our partners who have helped us. Blue Water Defense that provided the recycled textiles. Phoenix Fibers actually took the denim and converted into fibers and gave to us. NatureWorks and DuPont. NatureWorks provided the PLA and DuPont provided the Sorona, the two biodegradable binder fibers, and Crossplane Trading Company helped in opening up the recycled fabric trim waste, and Southeastern Nonwovens helped in the needle punching, and Cotton Incorporated and AFOA are helping in funding. So with that, thank you again for listening to me. And if there are any questions or comments, I'll be happy to listen to that. Thank you.
Thank you very much, Dr. Gajanand. Yeah, any queries, please proceed.
Any question?
Yeah, can I move to the next presentation? Okay.
Thank you.
Next presentation by Dr. Nastro Rosanna from Parthenope University of Naples, Italy.
Yes. Okay. Hello, can you see my screen? Okay.
Yeah, you can share now.
Okay. Oh. Okay. Good afternoon, everybody. And thank you for the introduction, of course, for introducing me. I am as a, sorry, I can hear, I hear something. Okay, I start now. Okay, there was some sounds, some kind of sound. Okay, so my name is Nastro Rosanna, and today I am a microbiologist, and today I will talk about how benefits the integration, the potential integration of urban green infrastructure with microbial cells technology could take to the modern and future cities sustainability. This research has been carried out in collaboration with the Environmental Research Engineering Department of State University of New York and the University of Surrey as well. So, okay. When we talk about urban green infrastructures, we are talking about artificial structures, essentially mimicking natural habitats. Here you can see some examples. I will show you some examples. So urban and urban forestry, and more modern forestry. Besides these ones, we have other examples like permeable pigments, urban trees canopies, and so on. Most part of these gardens that we are pretty used to see in our cities take different benefits to our cities. Essentially economic, social, and environmental benefits, which, okay, sorry, but I have to just, environmental benefits, like, for example, mitigation of climate change and heat island effects, or even the decrease of air pollution, the maintenance of natural resources. But of course, these structures have also the function to make our cities beautiful. So they they just serve to maintain also the landscape. So they have beneficial effects on people, so social and also effects on the way people feels in our cities. More importantly, if we consider on the whole the benefit, the environmental benefits of urban green infrastructures, we can sum up them in a few words. So that are essentially that urban green infrastructures contribute to the urban resilience, urban ecosystems resilience. It is pretty important right now because of the climate change issues as well. In this slide, and I won't go through the details about this slide, but I just want to show you the structure of most part of green infrastructure, which are essentially aimed at stormwater collection and management. As you can see here in figure 2, we have a retention cell. In this case, we have that stormwater, so the rainwater, pass through the surface and reach the storage tank that serves to store, to collect the stormwater, collect and distribute water as well, because stormwater through this stage, let's say, so it is distributed as well. And just a small part of water reach the native soil. It has been estimated that about the 4% of the storm water can penetrate the soil. But why we need to manage the storm water? So what is bad with storm water? The first issue is that with the climate changes, the flood episodes are increasing more and more. So our cities have to manage a great amount of water running off the streets, running off our streets as well. The second issue is that the rain, while reaching the soil, collect pollutants and particles that are present in the air, but also on the surfaces of buildings, cars, and on the streets themselves. So if not adequately managed, stormwater can reach the soil, the groundwater, and then the ecosystems. Yeah, the pollutants can enter the food webs and then reach the humans, reach us, consumers. So, just to give you an idea, but these are just the results of one of the many researches that have been carried out in time in the past 10 years. Gabe et al. In 2012 detected 88 priority pollutants listed among the European Water Framework in stormwater collected in 8 different zones of Paris. So as you can see, those stormwaters are essentially have a concentrated pollutants concentrated. I mean, they are heavily polluted with organic substances, metals, and even microbial pathogens. So that being said, our research question was, could microbial fuel cells technology, that is an emerging technology, help the treatment of urban stormwater and even urban soils? Because our cities, the soil of our gardens, for instance, our parks, are polluted with hydrocarbons and all the other pollutants that we emit in consequence of our activities. So can microbial fuel cells be transformed somehow, this stormwater, these pollutants, into a source of renewable energy while contributing to the removal of this, while contributing to the remediation of water and soil? So this was our research question. The starting point of our research was essentially the consciousness that in recent years, the microbial fuel cells applied to the bioremediation field has advanced more and more. Nowadays, there are different examples of pilot plants that are being tested in field. For example, for the treatment of marine sediments. But before moving forward in my talk, I just want to introduce to you the microbial fuel cells technology. It is essentially a new technology, as I said before, based on the metabolism of electroactive bacteria, which are widely spread in the environment. Those bacteria have a peculiar property. They degrade organic compounds, and at the same time, they are able to exchange electrons with an external acceptor. So in a few words, just to make it easier, they convert the chemical energy into electric energy and water. Of course, in our microbial fuel cells, we can also produce energy vectors like hydrogen, methane, but this is not the aim of this research. We just focused our attention to the production of electricity from pollutants. A basic microbial fuel cell is essentially made up by a single chamber, that is the anodic chamber, where anaerobic and anoxic conditions are realized. We have an anode and a cathode. The cathode is usually exposed to the air. So we put our fuel, that could be wastewater or polluted soil, sediments, and so on, in the anode chamber. There, bacteria break down the organic molecules, exchange electrons with our anode. Then we have a flow of electricity, of electrons, which reach the cathode, and then we have the production of water. It is important to stress that we can use essentially any kind of organic compound as a fuel. We do not need any chemical catalyst because all the process is catalyzed by bacteria. And these systems can work at environmental temperature. The last but not the least, these systems are considered carbon neutral because they are based on the microbial metabolism, that is something natural, So all the CO2 produced during this process has been previously fixed by other microorganisms or by other organisms. So the balance is essentially neutral in this case. In this slide, you can just see more or less how the electrons move. On the left side of the screen here, you see the single chamber MFC. On the right side, you can see a dual chamber MFC. That is essentially made up of a second chamber, the cathodic chamber, where usually we put water saturated with oxygen or other electron acceptor. So that being said, let's move through the application of microbial fuel cells as a bioremediation technology. As I said before, we usually at the lab scale have two-chamber or single-chamber MFC with a cathode exposed to the oxygen. But recently, many different layouts have been set up. An interesting one is this one, the plant MFC, that essentially have been developed to treat the water in the rice beds. In that case, they are particular. They are used for that application. So to have energy from rice beds, essentially. It is interesting, this application, because plants using their roots interact with bacteria, providing them also nitrogen, phosphorus in form of salts. So they contribute to both the degradation of organic compounds in water. In this case, it is a mix of water and mud, and at the same time produce electric power. On the left side of the screen here, you can see a sediment MFC for the remediation of marine sediment. Let's think about the sediments of harbors, for example. In this case, we have an anode buried in the sediments and a cathode floating in the water. More recently, there were also constructed wetland MFCs that have been set up and also already tested in field for the treatment of municipal wastewater, essentially municipal wastewater, even though there are some application for the treatment of industrial wastewater. As you can see, they are essentially constructed wetlands. We put a cathode and an anode as well. And of course, we have an external circuit here connected to a power management system. Of course, we have to collect the energy. We have to store the energy and then use it to power, for example, electronic devices or a light bulb or something like that. So, that being said, what we thought was, what about the application of microbial fuel cells to stormwater treatment? We saw that stormwater in stormwater, pollutants can be highly concentrated. Moreover, besides of pollutants, we can have other organic compounds that are naturally produced by other plants or something like that. We can have also a high concentration of salts, of mineral salts. So it should be not easy to treat stormwater. So what we did, a few years ago, so in 2017, essentially we carried out a first experiment just to test how efficient microbial cells could be in the degradation of, in this case, we used the pHs, but let's say complex molecules, and even complex and toxic molecules as well, because most part of those pollutants have toxic effects not only on humans or animals, but even on microorganisms as well. So what we did was a mineral solution, that is the Winogradsky solution, in our microbial cells that were single chamber archaeotode microbial cells. We put a microbial inoculum in our medium, and then we dissolved 5 pHs list on the priority pollutants at a quite high concentration, so ranging from 200 ppm to 550 ppm. Then we ran our MFCs at a temperature of 20 Celsius degrees, so not so high, not so low. And after 5 weeks, we had a degradation rate ranging from 17% of pyrene till about 53% of naphthalene. Of course, we had also some energy produced. On the left side of the screen, you can see the power, the polarization, the power curves that indicates that our system is working as an electric power producer. So just to, as an example, even the normal battery we use to fuel our mobile give similar power curves. When we just put different external loads and measure the current. So it is, I don't know if I hope it is clear. Anyway, coming back to our experiment, we then measured a certain amount of energy in terms of current density, that is 11 milliamps per meter cubes of water, but that is not so much amount of energy, but we expected this result because we put our bacteria in an extreme condition, because they did not have any other source of energy besides of pHs. So no glucose, no acetate, and pHs are quite difficult to break down. So we were pretty satisfied with our result. Then what we did was to move to another experiment. If some water can be treated in the storage tank, so as just with polluted water, it is also true that we in urban environment, we have our gardens and we have other infrastructures where essentially we have soil and plants growing on this soil. So what we did was to set up a system, a multi-electrode system, so with different anodes, different cathodes. We put the anode and the cathodes in soil, and then we let plants grow. Of course, we had a power management system as well. And we published, the results of this research on Journal of Clinical Production this year. What we did, essentially, we use as a proof of concept of the application of MFCs to the remediation of dry soil, because we know that the saturation, the water saturation, the saturation of soils depends on the climate conditions. So we do not, our microbial fuel cells should not work just when we have the ideal conditions. So when we have a lot of water, they should work also when the water is not enough. So we put some paddles, sorry, here, and then we put some contaminated soil provided by a company working in the hydrocarbons field, and then we built our fuel cells here with different, as you can see, these wires. They are connected to 3 cathodes, and then we have, sorry, I have a problem, with the multi-anode that underneath the soil itself. What we had after 4 weeks of treatment was that unexpectedly plants started growing by themselves. We did not plant any seed in the first stage, but the seeds already present in the soil started growing, started germinating, and then we observed the growth of plants. Thus signifying that MFCs are compatible with plant growth. And moreover, we had more plants grown in our MFCs rather than in our negative controls. So in our, let's say, untreated soil. We observed also a higher reduction in pH removal, 54% in comparison of our negative control. And we have also some energy produced on the average, more or less an amount of up to 1 watt per square meter of cathode surface and 1 amps for square meter of cathode surface. So that was the maximum we achieved. Of course, our MFCs, even in this case, did not work in ideal conditions because of the water scarcity. There was not so much water in our soil. So we observed sometimes a reversion of the voltage. That means that instead of giving us plus 1 volt, they gave us minus 1 volt, so a reversal of voltage. And this can be addressed to the dry conditions, to the dry soil. So, given all the data already available from the scientific literature, giving also the results we had from those preliminary experiments, and of course what we know about the urban green infrastructure, the role of urban green infrastructure in urban ecosystems, we just can sum up saying that MFCs can pollute also, can remediate even highly polluted water in conditions of scarcity of nutrients. That is something that happens in some water. And MFCs can also work in presence of a high salt concentration, as different experiments carried out on sediment or marine sediments proved that MFCs can be enough efficient to remove both heavy metals and both agents. MFCs can work with plants. They can be easily integrated with plants. This is quietly an expected result we had because we did not just have the plant growth, but we had somehow a stimulation of plant growth. is useful if we have to remediate soil or so essentially the soil, because plants themselves can further contribute to the remediation process. MFCs can have a flexible design types. As I showed you, I have showed you in my previous slides that MFCs can have many layouts, and we are still experimenting different layouts, different combinations, and of course we can set up MFCs for different scope. So we can just design MFCs for one specific scope. So moreover, MFCs can be scaled up. I didn't went through all these details because of time, but if you surf the scientific literature about MFCs, you can find many examples of how MFCs can be scaled up and how many layouts and combinations we can set up, even in terms of materials that we can use. Another advantage, in fact, is that MFCs can be built using cheap materials. I can say that our systems cost, at lab scale, of course, costed about €1, 2 euros, not more. And even if we consider scaling up, we can use graphite-based materials or ceramic materials, which are not so expensive as well. Moreover, and this can be another point in favor to the integration of microbial fuel cells to urban green infrastructure. If we think that modern cities are struggling for having much energy, so the energy demand is increasing more and more. And the integration of microbial fuel cells can take low-cost energy sources, even in countries with low economic incomes as well. So even if MFCs can provide at a big moment energy for the use for local use, but it can give a contribution to the transition from the the exclusive utilization of energy from fossil fuel to the utilization from renewable sources. In this case, we have energy from wastewater, for example. So this is another strong point in favor of the integration of microbial fuel cells to urban green infrastructure. So, in conclusion, let's say that we have just started to work about the integration of MFCs to UGI, urban green infrastructure. So we are moving the first steps in this direction. But we see great potentialities, even in potentialities because MFCs can provide soil water remediation and provide renewable energy. This is the transition of renewable energy, the water management, so the preservation of water are important steps that modern cities have to make for the transition to the sustainable cities. I wish to thank Professor Ted Endreny of ESF and Professor Claudio Vignone Russa of University of Surrey, with whom I carried out this this research, and I want to thank you for your kind attention.
Thank you very much for the informative presentation. And any queries, please proceed. In next presentation by Dr. Mauro Fois from University of Cagliari, Italy.
Hello?
Yeah, hello?
Yeah. Okay.
Yes, we can hear you.
You can see my presentation now? Can you see it?
No.
Mm. Okay. Now?
Yes.
Okay.
Yes, we can see it now.
Okay, thank you. So, good afternoon or good evening or good morning to everyone. Thank you for attending me to this presentation. My name is Mauro Fois, and I work for the University of Cagliari in Sardinia, which is an Italian island in the center of the Mediterranean, just you know where we are. Here I mainly focus my studies on endangered or rare plants species. Now I'm going to present you an overview on the application of species distribution models, specifically to the algorithm of Maxent, which can be used to predict climate change impacts on plant species. Well, climate change is one of major current and special future impacts on biodiversity. But this is not threatening in the same way all species or groups in all the areas. For example, in this slide, we can see that differences among southwestern Australia or Northeast Asia. We can see that, for instance, birds are generally less threatened than amphibians, and that all species are generally less threatened in arid steppes where large temperature excursion are intrinsic than in Mediterranean climates. Of course, climate is just one aspect in forcing species to extinction, which is often the sum of different forces, such as human-induced habitat fragmentation. And the niche of a species is determined by other physical or biotic factors, such as physical landscape or species-specific traits that might be considered when predicting current and future species niche or distribution. Well, species in general are especially threatened by climate change in islands or island-like environments, so-called like this, like mountains, for example. This is because islands have often limited habitat availability. And there are also physical barriers. For instance, let's take one plant, one bird with different dispersal abilities. If a future condition will be available only far from the current ones, for example, a plant with less dispersal ability will have less probabilities to survive. Than, for example, a bird with higher dispersal ability. No? Also, not all habitats will reduce in future. So a species living in habitat that will still largely present in future will have more probabilities to survive than, for example, a species living in a top of a mountain. So how we put into practice such theories? Well, with species distribution models or SDMs, the so-called SDMs. Very simply, SDMs are essentially a function where the habitat is determined by the sum of different factors. Among them, climate is one of the most important ones. And we can use the IPCC or other projections to predict also the future habitat suitability. Well, now I'm presenting in brief some example from the Mediterranean basin, and not only, but near, which is one of the 34 hotspot biodiversity for its high rate of endemicity, mainly for this. In particular, I focus my attention on endangered and endemic species that are intrinsically presenting two main constraints. The first one is that the distribution data is often poor because they are often rare species, and they are also beside climate change. So how we can face such one of the things, which is the most used algorithm in this sense, is especially useful because it was proved to show good performance with few input data. And it needs just present records and not true absence record too, like most of other algorithms. And also we can improve first runs with iterative search in order to enlarge the first dataset. And then we can use max and outputs to improve also the conservation status of a species. And finally, we can plan and, if possible, implement any conservation activity that would also help the species to survive in the future. So this is one example in Sardinia, where we apply these concepts with Gentiana lutea. This plant was initially known in Sardinia just in very few localities, more or less just three localities. Then we ran the first model, and we searched for further localities where the model was depicting other potential suitable areas. And with this approach, we start from about eight localities up to arrive to 58 localities, including also extinct localities that were confirmed by local expert testimonies. In this other review we published in 2018, we retained 28 research papers that were using a similar approach, and we found that performance were high with any kind of species and data set in terms of initial input data or the range or detectability. And we can see also the climate variables were the most used one, effectively, but also other variables such as topography or soil properties or land cover were also largely considered. So improving the current distribution and niche can help also improving the past, current, and also the future conservation status thanks to IUCN. For instance, in the case of yellow giant, we see in this slide that we updated the current conservation status that was critically endangered to endangered, which is one step less in, let's say. And thanks to the iterative search, this iterative search, so by improving the previous knowledge of its distribution. And also, we can predict, unfortunately, that will be again critically endangered in the next future. possibly with climate change. Also, we can use SDMs, like in this case, to investigate the current and future effectiveness of protected areas. In this case, we can see that the first two species from the left side, which are Fresia nana and Linaria flava, that are two species living respectively on top of mountains and sand dunes, will see a reduction of the suitable areas, also within protected areas. While other species, like Brassica insularis or Ruscus aculeatus, the other two on the right side, which are species, mid-elevation species, essentially, will find even more suitable condition in future. And no special protection then is necessary to be planned in the view of climate change. A similar approach shown with the Sardinian case was also replicated in Egypt with Rosa arabica, for example, and also for Primula boveana, especially in this part in the Sinai Peninsula. This stepwise approach will help planning a more effective conservation measure, both in situ or where otherwise impossible ex situ also. For instance, starting from where suitable conditions are now present and will be present in the future, in situ conservation measures are the best solution, both by protecting extant population or reintroducing the plant where is recently extinct due to other factors. If otherwise a population is finding a unsuitable condition in future, then ex situ conservation, such as seed banking, essentially, or assisted translocation are therefore necessary. With this approach also, we can put into practice this approach by planning and get financed some projects, like the introduction of yellow ginseng in Sardinia, or the conservation of Pancratium arabicum in Matru in Egypt. In these cases, we use the SDMs to locate the reintroduction in a place where present and also future suitable conditions are and will still present. This survival of in our case after first is allowing us to rate such approach as safe. So we can see that from in this experiment from in these last 6 years, the reintroduction is giving us around 60% of survival rate. So to conclude, the take-home message is that species distribution models are not just a tool for predicting future conditions, but also are a complementary tool to support the understanding of how a species is threatened and now and in the future, and to plan more effective conservation measures. Thank you for your attention.
Yeah, hello.
Yeah.
Yeah, thank you very much, Dr. Morofoy. If any queries, please proceed. So moving on to the next by Dr. Barca Caballero Hortas from University of Girona, Spain.
Good afternoon. Can you see me?
Yes, we can listen to you.
Perfect. I'm going to start by sharing the screen, if you don't mind.
Yeah, you can share your screen now.
Let me check. I hope you, can you hear me now? Yes?
Now it's clear.
Okay, perfect. So let me see, because I think you are seeing, no, no. Okay. It's okay, I don't know. Yeah? Okay, I'm gonna start. So, good morning, everyone. I'm Marta Caballero. I'm from GRMR and LIC from University of Girona. And I'm going to present our work in energetic and reproductive conditions of European sardine during the spawning season from 3 Mediterranean water bodies. I'm Marta, and my group is composed by Xenia Frigola-Tepe, Jordi Viñas, and Marta Muñoz. So thank you so much to the organization at the International Conference of Environmental Sustainability and Climate Change. Well, let's go. Oh my God, what's going on? Let me see. Now. Perfect. So I had to start by describing the species we are going to treat in this presentation. That is the European sardine, Sardina picharus. That is one of the most abundant and commercially important fish species in the Mediterranean Sea, comprising about 20% of the Mediterranean annual landings. Mediterranean sardine landings comprise almost the 25% of the whole European sardine production. It is a relevant species from an ecological point of view because it's a forest species that transfer the energy from low to higher trophic levels. It has a temperate distribution, and its abundance is highly dependent upon environmental and climatic conditions. It's because of that there is a concern regarding the climate change along the Mediterranean Sea. Also, other effects such as parasitism that at the same time could be somehow related with climate change could be affected somehow this species. It's because of that important international organisms as FAO or ICES are reporting and declaring that this species is under a serious risk in a context of climate change. In a global warming context, the increasing sea temperature in a semi-enclosed sea does not help to the normal migrations of this kind of the species, the ones that cannot tolerate these new conditions or conditions to the ones they cannot adapt. So sardine ecosystem has been threatened also due to changes in the mixing of the water layers, what brings nutrients to the surface, increasing phytoplankton availability for these species at the same time. And as you can see in the animation, along the whole year, there are many differences and heterogeneity in the whole Mediterranean Sea regarding temperatures. Because of that, we expect that they are differently affected, these areas. As you can see, these problems regarding climate change and global warming could compromise the life cycle of a pelagic species, and especially the ones with temperate cold waters affinities. Especially, it can have some effect in the reproduction period of the individuals. In the Mediterranean Sea, concretely, that mainly goes starting from November to March, with peaks of spawning in January and February. Gonad maturation process in teleos fish is a very, very sensitive phase, and suboptimal conditions of a new environment may have an impact on the final stages of ovarian maturation. as you can see, along this period of pre-reproduction, that is autumn and winter, during these last years, we can see an increase in the, well, a high anomaly in sea surface temperate conditions along the Mediterranean Sea. It's because of that, our hypothesis is that we are going to find differences in energetic and somatic and reproductive conditions along 3 areas in the Mediterranean Sea. It's because of that our objective was to analyze both energetic, somatic, and reproductive conditions of sardine individuals from 3 areas in the Mediterranean Sea. That was Northern Adriatic, Aegean Sea, and Northern Spain during the pre-reproductive and reproductive seasons, that is autumn and winter, in 2019-2020. So we are going to show you the different regions that were defined by the General Fisheries Commission for the Mediterranean, the different geographical sub-areas that we studied. That is Northern Spain, that is Northern Adriatic, and that is Aegean Sea. These are the number of fish we used for this study. These individuals were sampling by commercial fisheries from 21st October 2019 to 21st March 2020. First of all, in order to carry out our analysis, we measured some, and we took some morphogravimetric measurements that were total length, total weight, eviscerated weight of the fish, gonad weight, and liver weight of the sardines. Then, in order to perform the energetic somatic condition analysis, we measured the tissue fat content with a distal fish fat meter. Also, we measured somehow the mesenteric fat scale by a visual scale, and we calculated the relative condition index, that is Leckreen factor or Leckreen index, that takes into consideration the expected weight regarding the observed weight, take into consideration as well the length of the fishes of the population. And also we measure the hepatosomatic index that measure the weight of the liver regarding the weight of the fish, the viscerated weight of the fish. For the reproductive condition analysis, first of all, we classify the individuals into males and females, and we determine the reproductive stage at the fish was in that moment, into immature, developing, spawning capable, active spawner, regressing, or regenerating. Also, we calculated the gonadosomatic index that takes into consideration the weight of the gonad regarding the eviscerated weight of the fish, that is somehow the amount of energy that the fish transfer to reproduction. Regarding the statistical analysis, after perform the homosedasticity and normality test, we saw that we had to use Kruskal-Wallis one-way analysis test. Then, in order to check those differences, we use post-hoc Tukey's range test in order to see differences among, for example, sex ratios. We use Pearson's T-squared test, and to see the correlation among some parameters, we use the Pearson correlation. And also, we took as statistically significant a p-value above 0.05. So in here we have some results regarding this energetic and somatic condition analysis. First of all, we have to say that northern Spanish sardines have the most mesenteric fat. Also, Aegean sardines have the highest relative condition index, that is at the same time similar to the one, have the highest relative condition index, and also the condition index of Northern Adriatic and Northern Spanish one were somehow similar. And regarding the tissue fat content of Northern Adriatic sardines, we can see that is much lower than the rest of the groups we analyzed. But when we go to the analysis taking into consideration the liver, we can see that the Northern Adriatic, the ones that have less tissue fat content, at the same time they have a higher liver weight, also a highest hepatosomatic index, of course. And well, we have some potential hypotheses. It could be related to maybe allocation of the fat in a different way than the other groups. As we can see, teleos exhibit striking changes in internal biomass allocation in response to variation in acclimatization temperatures. In order to permit the maintenance of high level of biological activity in different body organs of the fish. And also in this taxa, genetic variances are seen in the trend to store energy. So we tried to check how is it going by doing a kind of correlation among the hepatosomatic index and the tissue fat content and the hepatosomatic index regarding the mesenteric fat scale, because our hypothesis was if these fishes are allocating differently the fat, we had to see some kind of negative trend. While they are accumulating more fat in the liver, they are going to accumulate less fat in the tissue fat content. However, we saw significantly positive correlations. And when we have a look to the literature, it's well known that sardines accumulated the most of the fat into the viscera, muscles, and so on. So it does not seem to be that there are differences regarding the fat accumulation in different locations. So that we thought maybe it's because there are some differences in feeding and how the fat is going to accumulate because of the source of the feeding. So when we have a look to the sources of feeding of these fish, we can see that they feed some phytoplankton, and concretely phytoplankton abundance during the reproductive season is different along the whole Mediterranean. And as you can see in this time series, for example, and in our case, when we check autumn and winter of our years of sampling, we can see in the frame you have in here, in Northern Adriatic, we found abundance of phytoplankton is skewed to the right, what means that there is much more phytoplankton in this season than in the case of Aegean Sea and Spanish coast. It's because of that we were reading and we saw that phytoplankton in this season is mostly diatoms that they accumulate somehow in the liver in this point. So regarding the reproductive condition analysis, we saw an overlapping regarding the gonadosomatic index in Northern Adriatic and Northern Spanish sardines, but not in the Aegean Sea. Also, Aegean was the location with the highest gonadosomatic index shown in all the stages, but not in the regressing one for this population. If we take into consideration the months of sampling, the only month that coincide all the populations we sample was in February, and you can see that the Aegean Sea was the location where we could find the highest percentage of individuals able to spawn. If we go location by location, we can see that, for example, regarding the Northern Adriatic sardines, spawning occurred at least from December to February, consistent with previous investigations in the area. However, we are seeing a high percentage of regressing sardines. And which is our explanation? In this time of the year, the temperatures were especially higher for this year and this month, so that could be somehow making the spawning season to be faster and to be finishing early as it was expected. Regarding the Spanish sardines, the spawning season extended from November to March, according to review data, for example, from Cole and Bellido of 2019. And regarding the Aegean sea sardines, we had to say that the spawning period was attributed to December and January, February. However, we know that the temperature has something to do with the spawning, of course. And in this temperature map, we see that, for example, that is October and that is November. And in the area of the Aegean Sea, 16 degrees were reached. It's because of that we start to see some sardines able to spawn in this month, in November. If we take into consideration somehow the time series, we can see that we have lowest values in gonadosomatic index, for example, in the case of the Northern Adriatic sardines. However, when we check the Aegean sardines, we have higher gonadosomatic indexes, that is, most investment in reproduction for these sardines than previous years. So how can we explain this? Is because could be related to there is some gonadosomatic index sex differences, and we are not taking into consideration the amount of females and males we have, and that is having some effect on this. It's because of that, first we check the gonadosomatic index in the 3 populations, and we saw the differences among females and males. And we can see that, for example, for Aegean sardines and Northern Adriatic sardines, we are seeing difference in this parameter, but not in the Spanish ones. So when we were reading, we saw that the general pattern of higher gonadosomatic values in females than males is like this in fish, but it's not like that in Sardina pizzardus in general. However, in our case, we are seeing some differences in 2 of the 3 populations analyzed. Surprisingly, when we check the sex ratios for Northern Adriatic populations and Northern Spanish population, we saw a sex ratio close to 60%. What is expected in animal population? That is not 50-50, but 60-50 in the number of females. However, when we check Aegean sardines, we saw a 24% of females, what is somehow weird. And there were no differences among the autumn season and the winter season. So these gonadosomatic index differences among females and males are not having any effect if we compare, for example, among northern Aegean Sea and northern Adriatic and Aegean Sea in terms of the effective sex ratio, because we even have less females. When we check the sex ratio of other studies, we saw that this pattern was not like that. So something is happening in this year. But also, we were reading in the same area an article that they were saying that this kind of segregation, because we saw this segregation also due to a spawning behavior in females. That is that the larger the fraction of females that were or will spawn the night of sampling, the higher the possibility of a male bias in the sample sex ratio. That is, females were somehow hiding or migrating toward other areas in order to avoid predation or the effect of fishing. So now we are going to see the energetic condition and reproductive condition interactions. And when we check the trends of the curves regarding the gonadosomatic index and the tissue fat content, we are seeing an opposite trend. That is, when gonadosomatic index increase during the active spawning season, the tissue fat content is lower. because the energy resources that are allocated during the summer, and they are going to be waste somehow during the reproductive season. However, when we had a look to the KN, or to the relative condition index, we saw that this index is not becoming lower, what was quite surprisingly, as you can check, for example, in other studies. That is, we can see a lot this trend in the Aegean sardines. And also we had to say that regarding the relative condition index for this population, the Aegean one, the KN, the condition was much more better for this 1999, 2000 and 2001 than these years that we are analyzing. But for example, regarding the gonadosomatic index, we are seeing an increase in this index. So we don't have the answer for this by the moment, but we are working on that. And the conclusions of our study was that Northern Adriatic sardines have significantly lower tissue fat content, but heavier livers and higher hepatosomatic index may be related to an easy access to phytoplankton, concretely diatoms that are abundant in this season during pre-spawning and spawning season. Also, an acute regressing phase was observed in February in sardines of Northern Adriatic, coinciding with an increase in the increase of the temperatures in the area during the season. Also, a young population individuals invest the most energy in reproduction, with the highest relative gonadosomatic condition index. Gonadosomatic index of active spawners in Aegean Sea in 2019-2020 seemed to be higher than previous years. However, the condition factor is lower, and the sex ratio is unbalanced in the Aegean population, with a low percentage of females, that was 24%, that could be related somehow with the reproductive behavior. So for future studies, we would like to contrast in depth the causes of condition differences among the study areas, also to investigate the bias in sex ratio in Aegean Sea sardines that could be related somehow with an inherited phenotype. Maybe studying epigenetics could be a nice approach. Also, we want to look for the cause of the increase in the relative condition while spawning. And as well, we would like to study the lipid composition in the liver to determine their main source of it, and if that is related somehow with this diatom abundance in the area. So thank you so much for your attention, and if you have any kind of question, don't hesitate to ask.
Now, well, will we have a time to taste your sardines?
Sorry, could you repeat?
Will we have a time to taste your sardines? Somewhere, somehow. Thank you.
Thank you. porque si no, mira.
Hi, good afternoon.
Yeah, we see you. No microphone. No voice. We don't hear you.
I think she needs the permission of the organizer to join. Like there is a kind of message that appears to her in order to ask the permission for join, and the organizer had to say that okay.
Hello. Hello. Can you hear me?
Hello.
Yeah,
Can you hear me?
you are online.
Yeah, I'm very sorry for the interruption. Internet was disconnected. So next presentation by Dr. Xenia Frigola from University of Girona, Spain. Dr. Xenia, you can start your presentation.
We can't hear you.
Hello,
Push the
Dr.
button.
Dr. Xenia, we cannot hear you. Can you increase your volume?
You have to push the button.
Dr. Xenia, can Hello?
Hi, can you
Hello?
hear me?
Yes, we can hear you now.
Okay, I'm speaking with the microphone from my colleague.
Okay.
So I will begin now. Well, hi, my name is Chenefrigola Tepe. I research in the Institute of Ecology in the University of Girona. And today I will present you the potential relationships between parasitism, condition, and water temperatures in sardines along the Catalan coast. In this project took part Marta Cabello Huertos, who present before me, Jordi Viñas, Marta Muñoz, and me. The European sardine is a cold water pelagic fish of the Clubate family with a high gastronomic value. Sardine has a lipid fraction rich in omega-3 fatty acids and low cholesterol values. They have a fast growth and a short longevity, and thereby they do not accumulate heavy metals nor pesticides in their tissues. Sardine is a key species in the marine ecosystem, but also a very important fishery resource. It constitutes the base of the Mediterranean food chain fleet. The minimum legal landing size is 11 centimeters. As we can see in the map, the sardines live in the Mediterranean Sea, in the Black Sea, and in the northeast of the Atlantic Ocean, from the North Sea to Senegal. The feedings varies according to the local plankton composition. Sardines feed on small copepods, but also on cladocers, diatoms, anchovy eggs, etc. In the last year, sardines got into a critical situation. What is happening? The annual catches in the Mediterranean Sea and in the Atlantic Ocean have been decreasing since 2006, as we can see in this graph. And the low abundance causes significant socioeconomic consequences for the fishing fleets of Portugal and Spain, causing concerns among fishermen. Moreover, sardines have lowered their fat content and their size of sexual maturation is smaller, with consequences in fecundity. At the same time, the quality and the quantity of the eggs have decreased. Why? The main factors are fishery, climate change, parasitism, and pollution. The intensive fishing interacts with the environmental changes by promoting and accelerating these housing sardines populations. They extract the larger individuals, causing a decline in the total average length, and this would lead to a decrease in the reproductive contribution of the population. So, moreover, the seawater temperatures rise is affecting the cold water species, especially in the Mediterranean Sea, because this is a semi-enclosed area where this displacement of the population is limited. So the temperatures influence the productivity of the ecosystem, as well as the seasonality of the sardines reproduction and the survival of the developing larva. Moreover, another cause of the low condition could be nematode parasites. For example, Histerotilatum aduncum has a higher prevalence than before. Parasites can affect condition, but also reproduction and mortality. So, the main goal of this project is to evaluate possible relationships between parasitism and the thermal regimes affecting sardines condition distributed along the Catalan coast. The study area is located in the coast of Catalonia. As we can see on the map of Europe, Catalonia is located in the northwest of the Mediterranean Sea, so in a limited area because sardines can go farther north. We analyzed samples during an annual reproductive cycle from October 2019 to October 2020. But we couldn't afford to analyze samples during April and May because of the situation of the coronavirus. So the samples were captured from two different thermal regime areas. We have samples from a colder area in the north with a thermal annual mean between 16 and 17 degrees. As we can see, this area in blue, and a warmer area in the southern between 90 and 20 degrees in green. So, the methodology. First, we wanted to analyze the sardines condition. A higher lipid content is associated with a higher survival rate, a higher reproductive success, and a higher growth rate. In our project, the sardines condition is obtained by the combination of these three index. First, a bioenergetic index using the distilled fish fat method. This is a non-lethal method which allows the rapid measurement of the total lipid content. The distilled fish fat method emits microwaves that estimate the water content and gives us the percentage of the total lipid content. Second, a visual mesenteric fat scale. We established 7 stages of mesenteric fat in the visceral locality of the sardines. So stage 1 is the lowest amount of fat, and stage 7, the highest amount of fat. And finally, a morphometric index, the latent condition factor. This index is calculated with the expected weight and the observed weight. A larger mass at a given length corresponds to a better condition. So the Kn values under 1 define that sardines are not in their best condition. With respect to the reproductive cycle, we define the sex of each individual samples. And we calculate the gonadosomatic index, GSI. This index relates the gonad weight with the eviscerated weight of the individuals. Sardine is a batch fauna. That means it generates several batches of eggs during each breeding season and then expels them. This reproductive strategy follows the conceptual model postulated by Brown-Peterson et al. In this model, we can see all the gonad development phases. So, gonads are immature when sardines have never reproduced before. When sardines become mature, the gonads begin the developing stage. Gonads increase in size, but the oocytes and the sperm are not visible macroscopically. Then the gonads become spawning capable. They are ready for the reproduction but have not yet begun to spawn. We can see vitellogenic oocytes and sperm in the spermatic ducts. In the deeply spawning stage, we can see the latent eggs and empty spaces between them because the gonad is already expelling the eggs. Then in the regressing stage, ovaries and tests are still large but almost empty. And finally, gonads go through a regenerating stage. So finally, we characterize the parasites by nematodes, comparing the two thermal areas. The aim is to identify and quantify the nematodes in the visceral cavity, following taxonomic keys and description. Finally, it is statistically analyzed with a program called quantitative parasitology. In the results, the graphics show the percentage of each gonad development stage seen along the annual sampling. In sardines from the Catalan coast, the spawning period starts in October-November and shows the main peak in January-February. When gonads are almost empty, they are in the regressing stage during March, and finally goes through a non-reproductive season in the regenerating stage during June, August, and summer. So the sardines condition. The box plot shows the mean total fat content from sardines from the north and sardines from the south. We obtain significantly differences between coasts. Sardines have a better condition in the colder northern island. Then the figure beside shows how the GSI varies significantly along the reproductive cycle, being higher during the spawning stage. The energy used in reproduction comes from the lipid content stored over the feeding season in summer. So the large variance that we can see in the total fat content from the first graphic is because it varies greatly throughout the reproductive cycle. As we know that the lipid contents varies a lot during the reproductive cycle, in the following graphs, we represent the total lipid content, the mesenteric fat amount, and the Lutgrens condition factor throughout the reproductive cycle for both coasts. We can see in green the northern coast and in red the southern coast. As the GSI increase, the total fat content and the mesenteric fat decrease due to the energy demand involved in the reproduction, in line with its capital breeding strategy. Then, during the spawning season, the northern coast has a higher lipid content and a higher mesenteric fat amount than the southern coast. Moreover, as we can see in the third graphic, the Kn values in the southern coast are lower than in the northern coast. The Kn values are below 1 almost through all the cycle. Sardines are not in the best condition, so we can only see that during the regenerating stage, the Kn is over 1. That is when the sardines feeds more intensively. Then that means that the environmental condition in the Gulf of Lyon has a favorable effect in the condition of sardines. This is probably caused by sardines' affinity for cold water. An increase in temperatures causes a decrease in physiological condition because the thermal variation makes resource less available to be consumed by sardines, and moreover, metabolic traits increase. Sardines from the Catalan coast are infected by one nematode in larval stage. It appears with a significantly higher prevalence, mean intensity, and mean abundance in warmer southern waters. The prevalence is 24 in the north and 31.2 in the south. Sardines act as an intermediate host for these nematodes until the larva can infect the final host and acquire the adult form. Stereothelatum aduncum is found in sardines as it uses copepods. Copepods are the main food source for sardines as an intermediate invertebrate. So the rising temperatures affect the presence of parasites and their life cycle. Moreover, stratified waters favors the transfer of these nematodes. Then, these two graphs shows on the one hand the prevalence of Stereothelatum aduncum, and on the other hand the average abundance according to the total length. Medium-sized sardines between 14 and 17 centimeters have the highest prevalence and abundance. So sardines with a higher length have less nematode parasites. Stereothelatum aduncum is higher in sardines with intermediate length, probably due to negative consequences, due to change in diet according to age, or because the negative consequences on growth. The juveniles feed more on phytoplankton and the adults on zooplankton. Stereotolacium aduncum Stereotolacium aduncum is not harmful to humans, as anisakis could be. Humans are not the final host of Stereotolacium aduncum. When we ingest one of these nematodes, the larva cannot develop to other stages of life and are excreted. So, however, can they affect the condition of sardines? The following graphs comparing the total lipid content, the mesenteric fat amount, and the KN throughout the reproductive cycle between parasite and non-parasite individuals shows that there are no significant differences between them. So parasites does not seem to affect the condition of sardines on the Catalan coast. But if we have a look on the following figure, we can see how affect the number of nematodes in the total fat content, and we obtain that these two variables are slightly significantly related. So the intensity of nematodes seem to affect sardines conditions. Most of the telos fish have a higher GSI in females than in males, but studies with sardines find that these are an exception. In our study, males have the same GSI than females. Our study has observed, moreover, a higher number of females. This pH produced by more females can lead to sperm competition between males in order to fertilize a higher number of eggs. Consequently, the gonads of the males tend to be larger in relation to their body size, and then they have a higher GSI. Moreover, the isometric growth of sardines have opposite direction. Males lose weight as they grow, while females gain weight. As we can see in the table, there are no differences in prevalence, mean intensity, and mean abundance of Stereotolacium aduncum between sexes. And finally, comparing the condition index along the reproductive cycle, we find that there are not significant differences between males and females. We can see differences in the mesenteric amount between sex in the spawning capable stage, in which females show a drastic drop in mesenteric fat. This is because of the higher and faster demand of the energy for the vitellogenesis of the oocytes. And finally, the conclusions. Individuals from the Catalan coast begin the spawning season in October, November, with the main peak between January and February. The condition of sardines varies during the reproductive cycle. It decreases when the GSI increases. Sardines from the colder north have significantly better condition than sardines from the south. They show a significantly higher total fat content, mesenteric fat, Kn values, and the parasites caused by sardines' affinity for cold water. Then sardines from the Catalan coast are infected by one nematode species, Stereotolacium aduncum. It appears with a significantly higher abundance in warmer water from the source. And finally, the intensity of nematodes appears to affect sardines condition. And that's all. Thank you very much for your attention.
Thank you very much, Dr. Sinya. And any questions? Please proceed. So next presentation by Dr. Adijok Lufemi from Tshwane University of Technology, South Africa. Dr. Adijok, I have made you the presenter and you can share the screen now and present your talk.
Okay, I'm trying to see.
Yeah, we are able to see your screen. You can start your presentation.
Okay. 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 Like as we just said now, my name is Adejoke. Please let me just do something quickly. Actually, okay. I think, can you see my screen now?
Yes, we are able to see your screen.
Okay. Good afternoon, everybody. My name is Adejoke from Tshwane University of Technology, South Africa. Just like you mentioned, I'm from South Africa, one of the universities. The name is Tshwane University of Technology, and I'll be presenting on this topic, low carbon awareness among students from a South African university. The study I'm going to be presenting is a preliminary study. We just decided to go for this one, so that after this one we can go for conduct a larger study. And like I said, the topic is on low carbon awareness among students from the South African university. And I have there my other colleagues, Andile Miji and Mwembiwa Nicola. So just like many people have been presenting on climate change, as we all know that for many years now, our planet has been and is still being faced with several devastating challenges which have adverse effects on the planet and general ecosystem. And one of such challenges, like we know, is a continuous emission of carbon dioxide and other greenhouse gases into the atmosphere, which has brought about the so-called environmental crisis threatening our world today. And as we all know, that these are primarily caused by human activities. They are caused by human activities primarily by mining and combustion of fossil fuels. And as we all know, that certain industrial activities are known, certain industries are known to be responsible for this, for the emission of dangerous substances, like I've already said, greenhouse gases and carbon dioxide into the environment, which has led to climate change. Like we have all been presenting, everybody has been presenting on climate change, and as we know that from climate change, there are other related issues that are threatening our environment. And several reports have noted that of all the many environmental issues facing us, climate change is the biggest problem, which has caused a great threat to human health in the 21st century. And over 150,000 deaths are estimated to occur annually as a result of this. And between 2030 and 2050, it is reported that an additional 250,000 deaths is expected to occur per year, apart from malnutrition, malaria, diarrhea, and other, effects like that. And for instance, in South Africa, climate change has been a serious problem over the years. Why? Because this country, fully depends on coal for electricity generation. So, and it is reported about South Africa that this country is one of the biggest emitter of greenhouse gases in the world, which has led to climate change. And the country is also the 12th highest carbon dioxide emitter in the world. And like I've already said, that what makes this country one of the biggest emitters of greenhouse gases in the world is because the country, South Africa, just like other countries, depend fully on coal for generating electricity. And this electricity generation takes place in a town called Witbank. And if you go to Google, you want to read about this particular town. This is where a town in South Africa where the electricity in South Africa is being generated. And this particular place is known to have the dirtiest air in the world, according to several reports. And this problem has affected, the health of the people, it has affected plants and animals, and the general ecosystem. And this has also, a great effect on the economy. And just like we all know that not only in South Africa, in all the nations, several nations of the world, this climate change has had a great effect on human health, animals, and it has, many plants. As a result of this, many plant and animal species have gone into extinction, as a result, because the environment is no longer conducive for them. And I want us to know that in the face of all these challenges, if you go into literature, several studies have reported that many people are not aware. Several people are not aware of of this problem, called climate change and other environmental issues. And developing countries are reported to be the most vulnerable to the effect of climate, and yet people in the developing countries, many are not aware of this problem. If you ask anybody, I've asked some people quite a number of times, and asking if they have heard about climate change. Many of them don't even know what climate change is. And that's why we've been talking about the matter of educating people. What we call climate change education, what we call educating people about the different environmental issues that are happening around us. And for many years now, the governments of many nations, of the nations, and various international bodies have tried to address, have put a lot of measures in place to address the problem of climate change. But despite all these efforts, several reports have indicated that the problem seems to be getting worse every passing year. And one important strategy that was adopted during one of the past UNFCCC, in addressing this issue is the development of low carbon economy by every country. In this convention, the government of every nation was advised to reduce the emission of greenhouse gases to minimal levels. And like you all know, the definition, we all know what carbon, I'm sure many of us know what low carbon economy mean, which means another name for that is low fossil fuel economy. Since it's been reported that what is actually responsible for climate change is the emission of greenhouse gases into the environment, which is caused mainly by the burning and combustion of mining and burning of fossil fuel. So low carbon economy, according to this researchers, is a concept that refers to a minimal output, that is a reduction of greenhouse gases, emission into the atmosphere. According to Environment 2016, low carbon economy also refers to that economy where people are mostly collaborating to reduce the amount of carbon dioxide emissions in any form or in various activities emitting from daily life and from production process of the factory or industry. It is to be noted that reduction in the emission of greenhouse gases to a minimal level, according to IPCC, will go a long way in minimizing the adverse effects of climate change and the effects it can have on the health of people and all of those stuff. And a group of researchers in the recent study also reported that low carbon economy, reported that in a low carbon economy, a different lifestyle will be adopted. The society will make more use of the renewable resources and minimize the usage of non-renewable resources. In South Africa, like many other nations, because the problem is getting worse and worse every day. So this country, South Africa, It's in the process of changing, just like it was advised in the convention that nations of the world should reduce, the emission of greenhouse gases to a minimal level. So for some years now, South Africa has been in the process of reducing, of changing from a high carbon economy to a low carbon economy, has pledged in that convention to reduce the emission of greenhouse gases by 34% in 2020 and 42% in 2025. So I want us to know that South Africa, like other nations, is already in that process. And the major reason why this study, we decided to conduct this study, is to let the government know that it is very, very important that the planning should not be limited to the government alone, but they should try and carry the general public, especially the young people, along, because it will get to a point that all the people that are in the planning process now might not even be alive again, but the young people, the younger generation, will have to continue from there. So one of the steps South Africa is taking is to achieve this is by shifting, which I've already mentioned, from the use of non-renewable resources to renewable sources of energy. And as this process continues, I've already mentioned that it is very important that the general public are also involved and making sure that they are properly and adequately informed about this idea. So this education, like I've already said, or information, informing the young people, informing the general public, will go a long way in helping every individual, whether young or old, to begin to develop a low carbon lifestyle in their various domains, workplaces, homes, schools, and daily lives. And I've already mentioned that this is mostly important for the younger generation, because they will later grow up to be the next generation of leaders and decision makers in their various fields and domains. Oh, I'm sorry, I don't think I've been okay. I'm sorry, I've not been changing. I'm reading from another. Okay, I'm sorry for the. Okay, this is where I am now. That as the process continues, it's very important that the government also involve the general public and probably the young people, to carry them along so that they can also have know about what is going on. So this education is very, very important. Okay, I've already said that. So let me just go to low carbon economy. It's a new concept that was recently introduced in schools in some countries of the world, and quite a number of studies have been reported on this issue. Making the young people aware about what is going on in the environment, the problem of climate change, and how we can actually mitigate against the effect of this problem. So we can see on the slide that, for example, China, as we know, that it's a highly industrialized and highly polluted country. And awareness about low carbon economy has been raised from time to time over the years in this country. The same thing in Malaysia and some other countries. But in South Africa, little or no studies have reported about to know if young people are being educated about this matter. And that was what actually brought about led us to conducting this study. Like I said, that in South Africa, these one no studies have been reported. To the best of our knowledge, this present study is one of the first studies that will examine people's awareness, especially young people, about low carbon economy in South Africa. And that was why the authors of this study decided to investigate on this matter by first conducting a preliminary study among some few young adults from my home, because this study was actually conducted in my, among students from my home institution, because it was very easy for us. So we decided to select a few students, so that's why, it's a preliminary, it's a preliminary study. The study still continues. After this, we'll go to conduct a larger study. So I go to the methodology now. So the study employed a quantitative approach by means of questionnaires. This study, being a preliminary study, was conducted among few students in South African residents. In my university, there is a particular residence that is close to a company that's to a mining and combustion company. In this place, the residence is just a few meters away from the company. So that was how we decided to go. There are so many other residences in the university, but because this residence is very, very close to this mining company, so that was how we decided to select to go to that, to select our students, the participants from that particular residence. So we actually selected 200 students from that place, but at the end of the day, only 113 of them were able to participate. And there were, as we can see on the slide, there were about 7 blocks of residents in that blocks buildings in that residence. So instrument and procedure, data was collected by means of a questionnaire made up of 2 parts. The first part requested participants to provide demographic data such as gender and age. The second part comprised 17 items on a 3-point Likert type, type scale on low carbon issues, which were adopted from other questionnaires. So you can see, let me just move forward so that I'm not going to waste time. So we go to the results, findings, or we decided to determine student low carbon awareness, which when we analyze by descriptive class, we were used to perform this task. This is percentages and an analysis of each of the items, but there were like few items that were on the questionnaires, about 17 items. And on the table, I'm going to be showing us as I continue. I have only 10 of the items. So by the time we analyzed the results, we viewed that majority, we just wanted to know from the items, to the questions we were asking the students, if they are actually aware of what climate change is about, what low carbon economy is about. Result of the analysis revealed that majority of them lacked awareness about this matter, about climate change generally and low carbon economy. I want to go to the questions now. To the questions, the items on the questionnaires. Okay, these are actually the. So we're just asking about one was talking about low carbon society, a concept I'm already familiar with. You can see that many of them reported that they don't even know what low carbon economy is about. Number 2 is talking about low carbon society strategy that aims at wanted to know if they actually know what's, we're talking about the definition, what's low carbon economy or society is all about. Then we went further to ask them, to know if they know, they are aware that South Africa is in the process of changing, from a low to a low carbon economy or society. Then South Africa is ranked, we were just asking all of those questions. We just want to know if they are aware about this concept we are talking about, low carbon economy. But we're looking at the results of the study. We could the result of the study actually revealed that they generally lack awareness about this matter. So we therefore recommended that, based on the result of this study, we could see that a larger percentage of the students. I'm just going straight to the recommendation now because of time. That's the result of the study revealed that a larger percentage of students generally exhibited lack of awareness about LC, low carbon society or low carbon economy, concept, which affected their attitude towards the environment. Therefore, there is a need for concentrated effort to be made to begin to educate these young ones about low carbon economic concept and how it will help in mitigating climate change and its impact on human beings, the ecosystem, and the environment in general. So that's the general recommendation, because looking at the results, reveal that students, the participants, majority of them lack awareness about this. So what we're just trying to suggest is that as this process is going on, the government should try and they should try and carry the young people, the schools, along, with regards to this matter, so that they can, because since they are going to be leaders of tomorrow, it will be very, very important if they are informed, they have information, to go a long way in helping them to also change their negative lifestyles, or behavior towards the environment. Through this education, people are made to understand that it is not only industry that are responsible. But what I'm trying to say that is that if you look at some of the questions, you're asking them that, do they switch off lights when they are not using? Many of them, they said no, they don't. Somehow, one way or the other, we think that it is only the industries that are causing, polluting the environment. Not knowing that even they themselves, through their own lifestyle, they also contribute to the pollution of the environment, through their lifestyle. So if they are properly educated, it will help them. This education will go a long way in helping them to also change their negative lifestyle, or behavior towards the environment. So through this education, people are made to understand that it's not only the industry that are responsible for the emission of greenhouse gases into the environment, but one way or the other, everyone is responsible through their daily, activity. So let me just go straight to the conclusion. I'm going straight to the conclusion because of time, because I've spent quite a number of, so in conclusion, as we were informed on low carbon awareness of young adults in Pretoria, South Africa, this result has shown that participants generally lack awareness with regards to low carbon issues. This will therefore serve as a baseline benchmark for intervention programs and provide information needed to promote low carbon economic concept in schools and in the country as a whole. So it is to be noted that this environment belongs to all of us. It is therefore very important that we care for it, protect it, and preserve it for the future generation. So the summary of this study is that, just like we have already said, that the environment, the matter of climate change is actually caused by the emission of greenhouse gases into the environment, and one of the solutions is by making sure that we reduce emission of greenhouse gases into the environment. And like I've already said, that every country is in the process of doing that. And so I'm talking from South Africa, that even as this process is continuing, the government should also make sure that they carry the young people along, by also educating them about whatever is happening, so that they can also be aware. So that as they also are growing, they are also growing up with this education, so that by the time they also get to positions where they have to make decisions, they will make right decisions. So I think that's all I needed. I wanted to that's all my presentation is about. So my presentation is about. Hello? Hello?
Hello?
Are you hearing me?
Yes, yes, we can hear you.
Yeah, I was trying to say that I think I'm done now. I don't know if there is any, I didn't want to spend much time. I don't know if there is any contribution or
Okay. Okay, that's fine. Okay, so next presentation by Dr. Manal Mostafa Jaki from Cairo University, Egypt.
okay. I was asking if there was any question or any.
Yeah, if any questions, please proceed. Meanwhile, Dr. Manal will be ready with his presentation. Okay, I made you the presenter, Dr. Manal. You can share your screen now. If any of the speakers from day 2 are interested to present now, please do let me know in chat.
Yeah.
Yes, you can share your screen.
Yeah.
Yes, kindly share your PowerPoint presentation.
Can you see my presentation?
No, just open it.
Okay. I don't know. I'm so sorry. There is some technical error.
It's okay. It's okay.
Yeah. Yeah. Share. There is something wrong. When I put share, the screen is gone. I don't know why.
Okay, just try once again.
Okay. I sent my presentation to Sarah. Can you open it from your email, please?
Okay,
If you
just
could.
give me a minute.
Yeah.
Are you able to see my screen?
Yeah, I can. Thanks.
Yes, you can present now. I will change the slides.
Okay, thank you. Hi, everybody. Good evening. This is Manal Zaki, a professor of veterinary hygiene and management. Okay, and it's my pleasure and honor to be with you now. I'm sorry for the time and for these technical errors. Okay, next slide, please. Okay.
Yeah.
My topic is effect of filtration in water quality parameter on epoching of bacterial disease in aquatic environments. And this piece of work is a teamwork, research teamwork So special thanks to my colleague Dalia and my colleague Shaima and my colleague Hanan, my colleague Mahmoud and Minna. And this is me, Manal Zaki. Next slide, please. Okay. We are talking about the climatic change, and we all know it's a synergetic relationship between national and the regional and the global issues. Next slide, please. Thanks. Okay. What about the global problem? Global problem is that the climatic change is abrupt surge in the catastrophic consequence of climatic change was primarily derived from the hydraulic change in global water, which gradually moved to our land. So when I said hydraulic change, so we are putting our aquatic species on the top list of the most impacted creatures. Next, please. Thanks. So when I'm talking about the national issues here in Egypt, I'm so sorry to say that, but we have a lot of issues here in Egypt. Something about the pollution of the water sources, our water sources with sewage, agriculture and industrial effluent, which represent threats, heavy threats to our native species along the Egyptian water basin. Next, please. Thanks.
Okay.
Next slide, please. I'm so sorry. Okay. So the climatic change, there is, I'm so sorry, the back one.
This one?
I'm sorry, the back
this
one?
One?
Okay, thank you. Yes,
okay,
this
okay.
one. Yes,
okay.
Thank you. Okay. So when we make a conclusions about the impact of climate change, we have to say global warming is first huge problem. Ocean acidifying increased drought and runoff flooding, increased ice melting, rise in the sea levels, and all these changes will affect our aquatic habitat and coral reef impacts. Okay, next slide, please. So here we come our project or our research that water of our aquatic creatures is easily subjected to contamination with sewage discharge and agrochemical runoff besides the waste discharged from our neighboring village without treatment. Okay. Additionally, our water resources is exposed to outbreak from bacterial infection among our aquatic creatures. The process animals which are also pathogenic to human, and this is additional risk to those handling or in or direct contact with water and fish in our facility. Next slide, please. Okay. So we have to improve the water quality for our aquatic creatures. Therefore, there is need to access the water quality and risk associated with microorganisms in our water and our cultures animal to decrease the serious illness or even death among our aquatic creatures. Next slide, please. Okay. Here is our sampling regions or localities. We took samples from Karun Lake, from Alexandria government, and from Maruteria Street. Okay. What's our aim of work? Our study aimed to determine some water quality parameter concerning the physicochemical and microbiological character, and to know the risk of bacteria in water on aquatic creatures in different fish production locality, which in the area which is that. Okay, the next slide, please. Okay, our methodology. Okay, we had water and fish sample from different 3 localities. Okay, that we said before: Alexandria, and Mariotea and El Fayoum government. All fish samples were examined clinically, while necropsy was performed on freshly dead and moribund fish. Okay, we examined our sample bacteriologically, okay, on all our sample, to differentiate different bacteria. Where is the sample? Fish organ we take gills, liver, and the kidney, and cultures with specific media to isolate Vibrio, Pseudomonas, and Eromonas. Next slide, please. Okay. All the fish samples were examined clinically. Okay, this is we examined this slide. The next one, please. Okay. Our study area, as I said, El Mariotea Street, Karun Lake, and Alexandria Province during. Okay. The water sample were collected in 500 milliliter screw cap bottle, okay, to evaluate the physico-chemical and microbial characteristics. Next, please. Okay. The number of our samples. Okay, from Lake Karun, we took about 30 Oreoclomas niloticus fry. Their weight was about 3 grams, and we took 50 Artemia shrimp. Their weight were about 1 gram, and 5 Tilapia zilli. From Mariotea, we only took about 5 Oreoclomas niloticus, and from Alexandria, we took 15 large shrimp from Alexandria province. Okay, next.
Yes,
We cultivate or we, yes, okay. Yes, this one, yeah, thank you. Our plates were inoculated with 1 milliliter of appropriately dilution sample for counting the different bacteria. Which bacteria? Staphylococcus, Vibrio, Remonas, and Pseudomonas species. Next one, please. And we made a genotyping characterization of the selected isolated bacteria. Next slide, please. Okay, our result. This is the chemical parameters we examined. pH, we found that pH are more alkaline in El Fayoum province, okay, followed by Alexandria, and then slightly neutral all shifted to alkaline in Mariotea Street. Carbonates and bicarbonates were high in El Fayoum and in Alexandria, less than in Mariotea. The same chlorides and sulfates are higher in El Fayoum and Alexandria than in El Mariotea Street. Calcium and magnesium and potassium and sodium, the same, are higher in El Fayoum province and Alexandria than El Mariotea Street. The next slide, please. Okay. This is the measurement of some heavy metals, zinc, copper, cadmium, and phosphate. And as we see, we detect zinc only in Alexandria, and copper only in El Fayoum province, and cadmium in El Fayoum and Alexandria province. For phosphate, we detect only phosphate in Alexandria. Next, please. Okay, and this is the isolated microorganism from water sample and fish sample. We isolate staph, Vibrio, Pseudomonas, Eromonas with different percentage and concentration in water and fish samples. Next slide, please. Okay, and this is the percentage of isolated microorganism, and we will discuss it in our conclusion. Next, please. We conclude that our night tilapia fry in Karun Lake showed Vibrio species in a percentage of 16.6%, Remonas 66.6%, and Pseudomonas at 16.6%. Sample of shrimp showed Vibrio in a percentage of 40%, Hormonus in a percentage of 20%, and Pseudomonas in a percentage of 20%. While Tilapia showed Vibrio in a percentage of 40%, Hormonus 40%, and Pseudomonas in a percentage of 20%. Next, please. Okay. While tilapia samples were collected from Mariotea stream showed no Vibrio species. Okay, just only Hormonus in a percentage of 80% and Pseudomonas in a percentage of 20%. In addition, our water sample were contaminated with heavy metal like copper, cadmium, and phosphorus. We have to say that our contamination of our water sources is just only one source. No, it's a multifactorial problem. It's a non-point source. It's not from industrial or from sewage or from agriculture, but it's a multifactorial problem. So we have to work on to lessen our contamination by many factors and many interaction from people and from veterinarians and from the local authorities. Next, please. This, I think, I finished now. Special thanks for you and for your effort, and it's my honor and pleasure to be with you. Special thanks to my colleagues, Dr. Hanan, Dr. Elshima, Dr. Dalia, and that's it. Thank you very much. And if there is any questions, I'm here.
Thank you very much, Dr. Manal. If any questions, please proceed. Okay. Okay, thank you very much, each and everyone, for joining the session today and for your patience and for your valuable time. So hereby comes to an end for the day 1 sessions, and tomorrow we'll start with the day 2 sessions at 9:30 a.m. as per London timings. And today 3 presentations have been rescheduled tomorrow. So Dr. Paul, Dr. Isam, and Dr. Sarah will be presenting tomorrow as per the scheduled timings. So thank you each and everyone for your valuable time, patience, and you can log out from this. And thank you. Have a nice day. Bye.
Thank you. Bye.